Yeah, hi everyone, welcome to PrepFusion. So today we are going to start multiple integrals. So we started with multivariable functions, like we understood what is the meaning of multivariable functions and how to plot them. Then we studied about coordinate system, which was very important, and then we studied about single integral. And after that we are starting multiple integrals. Now this is a very easy topic. Usually aspirant would find it tougher because they don't have good enough prerequisite. Now what would happen is that people would find that multiple integral is difficult, so they would directly jump onto this video. They would skip all these videos, they would directly come here, multiple integral. So if you are directly starting from here, then it might happen that you are not able to understand a lot of things, because I have cleared a lot of prerequisites here. Like coordinate system is a very important prerequisite if you want to study multiple integral. Otherwise it would become very difficult. So coordinate system is very important, right? Say same goes with multivariable function as well. Same goes with multivariable function part 2 as well. Here we have seen how to plot a 3D geometry. Okay, because we are going to deal in three variables now, no, right? Not only two variables. First we will deal in single variable, then we will deal in two variable, then we will deal in three variable, four variable, and multivariable as well. So how to plot and visualize multivariable function, that we have understood here. So they are very important. So directly if you are jumping on this video, then you might struggle in multiple integrals. I hope you are studying right from the beginning and then you are coming to multiple integral, and it will be a cakewalk for you. Have some patience, keep on looking at the screen. When I ask you to solve a particular problem, then you solve it. That's it. Okay, so let's get started. We are starting with the simple question. A road is placed along x-axis with its end point at L, 0 and 2.5 L, 0. What is the length? What is the length of this road? Sir, very simple question. What you are asking, 2.5 L minus L, what will be the length? Sir, length will be 1.5 L. That's it, sir. What you are asking, this is the answer. So what is the answer? Answer is 1.5 L. Yeah, I know this is the answer, but we need to solve using the calculus. Okay, we are going to solve using the calculus. We are building up the concept here, no? So we are going to solve using the calculus. How we will solve using the calculus now? So I told you, what is a small length in the direction of x? What is a small length in the direction of x? A small length in the direction of x is taken as dx. So if you want to find out the complete length, then what you will do? You will integrate dx from where to where? You will integrate the dx from L to 2.5 L. L to 2.5 L. So what is the integration of dx? That is x, and you are integrating from L to 2.5 L. 2.5 L minus L, that will be equals to 1.5 L. This would be the answer. That's it. Okay, this is the length. So this is how you would have done it. A small length in the direction of x is dx. So simply integrate dx from where to where? From L to 2.5 L. That's it. This is the answer. This is known as single integral. So a single integral is representing a length. Single integral representing a length. Sir, in the last lecture when we were studying about single integral, here what you said, fx dot dx, this is representing a to b, this would represent area. So sir, single integral is representing the area here, but here you are saying that single integral is representing the length. Yes, I am saying that, but I am saying a half statement. I should say single integral dot dx or single integral dot dy or single integral dot dz or single integral dot any variable would represent length. But this was single integral fx dot dx. So this is a separate thing, we will talk about it. Are you able to understand this point? So this would represent the length. Like usually I have seen a statement that single integral will represent the length, double integral will represent the surface area, and triple integral will represent the volume. That is absolutely baseless. Single integral dot dx would represent length. This is the conclusion that we have made till this point. Next question. We need to find out the arc length of the circle x square plus y square equals to 4 that lies in the first quadrant. So basically we need to make the circle x square plus y square equals to 4, but only in the first quadrant. So x square plus y square equals to 4. This is the circle we are supposed to make, but only for the first quadrant. So this is the complete circle, x square plus y square equals to 4, but we need to care about only the circle in the first quadrant. And what is the radius here? So the radius here is nothing but 2, right? X square plus y square equals to 4, radius is 2. But only we need to care about the circle in the first quadrant. So this is the first quadrant which we need to care about. That means we don't need to care about this much circle. We are not going to care about this circle. So now what is the arc length? Sir, it is a very simple question. So this arc length we are supposed to find out. This arc length we are supposed to find out. So arc length. Sir, the complete length was 2 pi r, right? The complete length was 2 pi r. Value of r is 2. But divided by 4, because this length plus this length plus this length plus this length, 4 into this length was your full length. So 2 pi r divided by 4. What will be the answer? Answer will be y. Why I divided by 4? Because this is the 1 by 4th part, no? This is the 1 by 4th part, 1 by 4th part, 1 by 4th part, 1 by 4th part. Combined it was 2 pi r. So 2 pi r divided by 4. So answer will be, sir, pi unit. This is the answer, sir. But this is how we are not supposed to solve. How we are supposed to solve? We are supposed to solve with respect to calculus. So let's solve it with respect to calculus. So what I need to find out? I need to find out this length. Now let me know when I am moving on this arc. When I am moving on this arc, in which direction am I moving? Do you remember the angle theta? Yes, sir. The angle theta is the angle measured from x-axis in the anti-clockwise direction in 2D coordinate system. In 2D coordinate system, sir, our radius was r and theta was the angle measured from x-axis in the anti-clockwise direction. Understandable? So when I am moving on this arc, in which direction am I moving? Am I moving in the direction of r? No. This is the direction of r. On this whole arc, what is the value of r? Let's call this arc as AB. So on the arc AB, value of r is 2, which is fixed. But at point B, what is the value of theta? At point B, what is the value of theta? Let's just say if this vector was here, if this vector was at point B, what would have been the value of theta? Theta would have been 0 degree, right? And if it is at point A, then what is the value of theta? That would have been 90 degree. If it was here, then theta would have been 45 degree. Here it would have been 30 degree. Here it would have been 75 degree. This is 80 degree. This is 20 degree, right? So when you are moving on this arc, the value of theta is varying, no? At point B, theta is 0 degree. At point A, theta is pi by 2 degree. I should not say pi by 2 degree. It is in radian, so I should say 90 degree. Right? So I am moving on this curve. The value of theta is varying, and in the direction of theta, how much do you move? From theta, if I move d theta, then how much do I move? I move for r d theta. I hope you remember. This is d theta, and this is r. So in the direction of theta, if I move d theta, then how much do I move on the arc? I told you angle is equals to, what is angle equals to? Arc length divided by radius. So what will be your arc? Arc will be r d theta, right? So this arc is nothing but r d theta. So my small length here is r d theta. So what will be my complete arc length? What will be my complete arc length? My complete arc length will be nothing but r d theta, and then I will integrate it. From where to where I will integrate? I will integrate with respect to what? With respect to theta only, no, not with respect to r, because r is constant. R is constant, that is equals to 2. With respect to theta, I will integrate. So with respect to theta, I will integrate theta from 0 to pi by 2, because here the value of theta is 0 and here it will reach pi by 2, and always the limit is taken from lower limit to higher limit, lower to higher. Theta to pi by 2 I will integrate. And what is the value of r here? The value of r is fixed, which is equals to 2. So take 2 outside. Integration of d theta will be theta only from 0 to pi by 2. Just put down the limit, pi by 2 minus 0. So answer is pi. This is the answer, pi unit. Sir, why it is necessary? Sir, very easily I would be able to get the answer, no? But we are building up the concept. We are building up the concept for something that is coming next. Okay. So what concept we have built up? On this particular arc, if I am moving, then my value of theta is moving, not the value of r. R is constant. Since the r is constant, then what I would do? in the direction of theta, how much do I move? In the direction of theta, I would move r d theta with the value of r being 2, and theta is going from 0 to pi by 2. So the complete arc length will be pi unit. So this you have to remember again and again. I am not going to derive it. In the direction of theta, how much do we move? R d theta. In the direction of r, how much do we move? dr. In the direction of rho, how much do we move? d rho. In the direction of phi, how much do we move? Rho d phi. In the direction in spherical coordinate system, in the direction of r, how much do we move? dr. In the spherical coordinate system, in the direction of theta, how much do we move? r d theta. In the spherical coordinate system, in the direction of phi, how much do we move? r sin theta d phi. I hope you remember everything we have studied in this coordinate system, which is very important. It will be completely used in this whole lecture. Okay. Otherwise, your multiple integral will become very difficult. Let's see this question. Find the area of the rectangular region in xy plane which is bounded by the line x equals to 0, x equals to 3, y equals to 0, y equals to 4. Can you draw all these four lines? Absolutely, sir. xy plane I need to make. xy plane I need to make, and I need to draw these lines. This is your x-axis. This is your y-axis. What is the line x equals to 0? X equals to 0 means y-axis. 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 Then x equals to 3. This is your x equals to 3. This is your x equals to 3. This is your x equals to 0. This is your x equals to 3. Then y equals to 0 means x-axis. This is your y equals to 0. Y equals to 0. Y equals to 0. And then y equals to 4. Y equals to 4 means this is your y equals to 4. This is your y equals to 4. This line is y equals to 4. This is y equals to 4. This is y equals to 0. This line is x equals to 3, and this line is x equals to 0. So what is the area bounded? This is the area bounded, right? Say yes or no. So can you find out this point? What will be this point? So this point will be x equals to 3 and y equals to 4. X equals to 3, y equals to 4. What will be this point? Sir, y equals to 0, x equals to 3. What will be this point? Y equals to 0, x equals to 0. Basically, on this point, what all curves are meeting? Y equals to 4 is meeting, x equals to 0 is meeting. That means x is equals to 0, y equals to 4. Right? So what is the area of this much region? Can you tell? Yes, sir, I can tell the area. What is this length? This length is 4. This length is 4. And what is this length? What is this vertical length? This vertical length is 3, right? Wait a second. Oh, sorry. This is from 0, 0 to 3, 0. No, so this much length is 3. This much length is 3, right? From 0, 0 to 3, 0. So this length is 3. And what is the vertical length? From y equals to 0 to y equals to 4. So this vertical length is 4. Right? So 3 and 4. So what is the area? Area is 4 into 3. That is 12. That's 12 unit square. That's the area. But sir, this is not how we are supposed to solve. We are supposed to solve with respect to calculus. So on xy plane, what is the small area we need to take? On xy plane, sir, the small area that we take, in the direction of x, if I work dx. In the direction of y, if I work dy. This is the small area we take, right? So what will be your total area? So total area will be dx dy. But now you let me know, you are putting the limit of x as well, you are putting the limit of y as well. Here we were putting only the limit of theta, so there was a single integration. If I am putting the limit of x as well, if I am putting the limit of y as well, that's why there will be double integration. I need to put the limit of x as well, I need to put the limit of y as well. So from where to where x is going? X is going from 0 to 3. Just look at this scenario. X is going from 0 to 3, right? In this whole surface, x is going from 0 to 3. 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 Say yes or no. So x is going from 0 to 3. And y is going from 0 to 4. 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 0 to 4. 0 to 4. In this whole surface, y is going from 0 to 4. Y is going from 0 to 4. So the limit of x is good. Now, so how you will solve this double integration? How you will solve? Sir, y I will keep aside. I will solve about y later on. First, I will solve the integration of x. X is going from 0 to 3 dx. First of all, I will solve this. You can take it separately. First of all, I will solve this. Okay, after that I will think of y. So x is going from 0 to 3. This is the scenario when both of the limits are constant. This limit is constant, no? 0 to 3, 0 to 4. So the limit is constant. So first I am solving about x. So what I am getting? 3 minus 0, it will be 3 only. So what you will get? Y going from 0 to 4. When I solve this, integration of dx will be x. Put the value of x here. 3 minus 0 will be 3 only. Dot dy. So 3 you take outside. Now you will solve for y. Y going from 0 to 4. Right? So limit of y is going from 0 to 4. So you can solve it. Answer will come out to be 4. So what will be the answer? 12 unit square. 12 unit square. This will be the answer. Okay. So this will be the answer here. This will be the surface area, which will be 12 unit square. Understandable? Very simple question, very straightforward, right? Let's go to the next one. Determine the area of the region in xy plane bounded by the lines x equals to 0, y equals to 0, x plus y equals to 2. Okay, let's get started. This is your x-axis, this is your y-axis. So x equals to 0 means y-axis, and y equals to 0 means x-axis. And what is the meaning of x plus y equals to 2? The meaning of x plus y equals to 2 is this line. The meaning of x plus y equals to 2. That means this point would be, I hope you know how to draw the line x plus y equals to 2. So this point would be 2, 0, this point would be 0, 2. And area bounded, so this much area is bounded, no? This area is bounded. So this is the area bounded. So they are asking about area bounded. So this bounded area we are supposed to find out. Sir, very simple. Sir, this area I can tell very easily. Sir, how much is this length? This length is 2. And how much is this length, sir? This length is also 2. So what will be the area, sir? Area is half into base into height. So area is 1 unit square. But this is how we are not supposed to solve. We are supposed to solve with respect to the calculus. So let me draw the diagram again. And let's solve it with respect to the calculus. So I am drawing the diagram again. Once more I am drawing. Okay. So this was the area bounded. This is the area. Only the bounded area I am making. This is the area bounded. And points also we will see. This point is 2, 0. This point is 0, 2. This is y-axis. And this is x-axis. This point is 0, 0. So this area bounded we need to find out. Sir, small region I need to take, what that would be? In xy plane, a small region if I need to take, a small surface area if I need to take, that would be nothing but dx dy. So what will be the surface area? Surface area would be, sir, integration dx dy. From where to where x is going? You would say, sir, x is going from 0 to 2. And from where to where y is going? Y is going from 0 to 2. You would say, sir, x is going from 0 to 2. And sir, y is going from, x is going from 0 to 2, y is going from 0 to 2. And then we will solve it. Once you solve it, you would get to know, sir, this would give me 2. And this would also give me 2. 2 into 2, answer is coming out to be 4, which is wrong. This is wrong. So when I said that x is going from 0 to 2 and y is going from 0 to 2, did I say correctly? Did I actually say correctly that x is actually going from 0 to 2? If I say x is going from 0 to 2, x is going from 0 to 2 and y is going from 0 to 2. That means this much region would be there, no? X goes from 0 to 2, 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 x goes from 0 to 2. Y goes from 0 to 2, 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 y goes from 0 to 2. So I have actually found out the area of this rectangle. I have found out the area of this rectangle. But this is what is not happening here. Now, this is not the scenario. If I say x is going from 0 to 2, x is going from 0 to 2, where y is going? So if you see the limit of y, so if you look closely, see the limit of y. What is the equation of this line? The equation of this line is x plus y equals to 2. So here what is y? Y is nothing but x. y is nothing but 2 minus x. And here what is y? Y is 0. Here y is equals to 0, no? So y is going from 0 to 2 minus x. Y is going from y equals to 0 to y equals to 2 minus x. Is that understandable to you or not? Basically, you have taken a vertical strip here. What you have taken? You have taken a vertical strip. Now you will move this strip. Move this strip. You can move this strip here as well. You can move this strip here as well. If you move this strip here, and you can move this strip here as well. In the whole surface area, you need to move this strip. In the whole surface area, you need to move this strip. When you are moving this strip in the whole surface area, your y is always going from y equals to 0 to y equals to 2 minus x. Y equals to 0 to y equals to 2 minus x. This is 0, 2. Here also from y equals to 0 to y equals to 2 minus x. It is always moving. You are moving this strip here as well. You are moving this strip here as well. When you move this strip, y is always going from 0 to 2 minus x, and you are moving this strip from where to where? If you look closely, just look at the bottom of the strip. The bottom of the strip is moving from x equals to 0 to x equals to 2. Just look at the bottom of the strip. The bottom of the strip is moving from x equals to 0 to x equals to 2. So this was the surface region. There was a strip. You started moving the strip. So when I am moving that strip, in the vertical direction, I am going from y equals to 0 to y equals to 2 minus x. But in the horizontal direction, I am moving the strip from x equals to 0 to x equals to 2. X equals to 0 to x equals to 2. Just look at the bottom of the strip. So bottom of the strip is going from x equals to 0 to x equals to 2. So if you need to find out the surface area, sir, this was correct. This much till this much point it was correct. Dx dot dy. Right? But you need to make sure one thing, that y will go from 0 to 2 minus x. Y will go from 0 to 2 minus x. And x will go from 0 to 2. Now always when you need to solve this kind of integration, where one limit is constant and one limit is variable, then you will solve the variable limit first and constant limit later on. So here variable limit will be solved first. Variable limit will be solved first. So this is not the correct way of writing down. How I would write it down? Sir, x is going from 0 to 2. So this I will see later on. But y is going from 0 to 2 minus x dot dy. So this I will solve first. Whatever the result I get, after that I will think of integrating with respect to x. So first I will integrate this one. So do you know the integration of this y going from 0 to 2 minus x dot dy? So what is the integration of dy? That will be y only. Y going from 0 to 2 minus x. So in place of y you need to put 2 minus x. In place of y you need to put 0. So answer is 2 minus x. So for this much, what answer we have got? 2 minus x. So x is going from 0 to x equals to 2. So for this much we have got the answer 2 minus x dot dx. So this we have solved separately, but with the time we will build up the practice that we will solve within one step only. Okay. Here we have taken a separate step, but with the time we will build up the practice that this much we don't need to solve separately. Okay. So a equals to, what is the integration of 2 minus x dot dx? Sir, that would be 2x minus x square by 2. Right. Integration of 2 would be 2x. Integration of x would be x square by 2. Limit going from 0 to 2. You just need to put the limit now. If you put the limit here, 4 minus 4 divided by 2. Here something wrong we have done. This was 2 answer. Answer was 2 here. Half into base into height. Answer was 2. Yeah. So if you put the limit here, 2 into 2, 4. 2 into 2, 4. 4 divided by 2. Then put the limit 0. 0 minus 0 will be 0 only. So what is the answer you are getting? 4 minus 4 by 2. 2 unit square is the answer. 2 unit square is the answer. That's it. This is the answer. So this is how we will solve it. Always, what is the issue? The issue here was, if I am taking x going from 0 to 2, y going from 0 to 2, I am ignoring the structure. The structure is triangular, not rectangle. If I am saying x going from 0 to 2, y going from 0 to, here also you could have taken the strip. What you could have done? Here also you could have taken the strip. Let's just say I take a strip here, which is somewhat like this. I have taken a strip which is somewhat like this. This strip I have taken. If you move this strip, just let me know, move this strip here and there. I have moved the strip till this point. I have moved the strip to this point as well. In both of the direction, I have moved the strip. Now let me know from where to where your y is going. Bottom of the strip is y equals to 0. Say yes or no. Bottom of the strip is y equals to 0. Bottom of the strip is always y equals to 0. And what is the top of the strip? Top of the strip is always y equals to 4. So top of the strip is always going from y equals to 0 to y equals to 4. And when you move in the direction of x, it is going from x equals to 0 to x equals to 3. X equals to 0 to x equals to 3. Here you move, here you move. But always we need to move from lower limit to higher limit. Always remember, the limit will be always taken from lower limit to higher limit. Lower to higher, lower to higher. So y equals to 0 to y equals to 4, x equals to 0 to x equals to 3. Now here someone would argue that, sir, why you have taken only the vertical strip? What if I would have taken a horizontal strip like this? So let's answer your query and let's take up the horizontal strip method 2. Because here someone would say that, sir, why only vertically? Why you are taking the variable limit of y only? We can take the variable limit of x as well, right? Someone would say, let's make the same structure again. I will make the same structure again, sir. No changes. Shaded region only we are making. The bounded region only we are making. This region we have made, sir. But my point is, this time I will do somewhat like this, that I will take a strip in this manner. I will take a strip in this manner. Arey bhai. I will take a strip in this manner. Now I know one thing. What is the value of x here? X equals to 0. And what is the value of x here? Using this equation, the value of x is, using this equation, value of x is 2 minus y. Value of x is 2 minus y. Now, sir, I will move this strip on the upper side and on the downward side. When I move this strip on the downward side, sir, this is where I will reach. This is where I will reach if I move this strip on the downward side. So on this strip, the value of x is here 0 only. The value of x here is 2 minus y. If I move it upper side, again, sir, the value of x is going from 0 to 2 minus y only. The value of x is going from 0 to 2 minus y only. 0 to 2 minus y only. And when I move this strip, sir, the bottom of the strip is moving from, let us say, I will start moving the strip from the bottom to up. So bottom of the strip is going from 0 to 2. Y equals to 0 to, what is the value of y here? Y equals to 0. And what is the value of y here? Y equals to 2. So when I move the strip is going from y equals to 0 to y equals to 2. So what will be the area here? Area here will be dx dy, dx dy. But x is moving from x equals to 0 to x equals to 2 minus y. But sir, y in this strip, y will move from 0 to 2. Y will move from 0 to 2. So first I will solve this variable limit. This much I will solve. First I will solve this much. How much? First I will solve this much. First I will solve this much and then dy. So what will be the area? Area is y going from 0 to 2. Variable limit I will solve first. So integration of x will be x only. Then in place of x you will put 2 minus y and 0. So 2 minus y minus 0. Similar thing. So answer would be come out to be 2 minus y dot dy. So when you solve this one, what you will get? 2y minus y square by 2. Similarly, here we got 2x minus x square by 2. Here you will get 2y minus y square by 2. Then you will put the limit from 0 to 2. Answer will come out to be 2 unit square. Same answer you will be getting here. Ditto same answer you will be getting here. And here as well you could have taken, in this example as well you could have taken the horizontal strip. If you take the horizontal strip, the same scenario would happen. X would go from 0 to 3 and y would go from 0 to 4. Is that clear to you? Limit will be always taken from lower limit to higher limit. Lower to higher. Lower to higher. Lower to higher. 0 to 2 minus x. 0 to 2. Lower to higher always. Is that clear to you or not? Absolutely, sir. Completely clear. We need to take the strip and solve the problem. Okay. Next question you will try on your own. Determine the area of the region in the xy plane bounded by the lines x equals to 0, x plus y equals to 2, x minus y equals to 2. Try doing it on your own. With respect to geometry as well, with respect to taking the strip as well. So did you understand here how we took the strip? Yes sir, we have taken the strip in this manner. We could have taken the horizontal strip as well, we could have taken the vertical strip as well. When I take the horizontal strip and move it up and down, what I see that x is going from 0 to 2 minus y, while y is going from the bottom end of the strip. This is the bottom end, no? The bottom end of the strip, it is going from y equals to 0 to y equals to 2, y equals to 0 to y equals to 2. Next question, again make the structure. Both of the lines we are going to make, and we need to find out the area bounded. This is your x, y. What is x equals to 0? X equals to 0 is this. This is your x equals to 0. X equals to 0. This is the line of x equals to 0 completely. X plus y equals to 2 is this. X plus y equals to 2. Although it will go like this, like basically the x plus y equals to 2 is this line. X plus y equals to 2 is this line. So this is x equals to 0. X equals to 0, y equals to 2. This is x equals to 2, y equals to 0. Right? X minus y equals to 2. So that could be written as y equals to x minus 2. Right? So the line would go somewhat like this. This is how the line would go. This is how the line would go. So this point is 2, 0. And what is this point? This point is y equals to x equals to 0 and y equals to minus 2. Okay, so these are the lines. What is this line? This line is, sir, x minus y equals to 2. And what is this line? X plus y equals to 2. We need to find out the area bounded. So this will be the area bounded. This is the area bounded. This is the area bounded. So can you find out the area bounded by the geometry first? No calculus, nothing. Only by the geometry. So if I look by the geometry, I would see that, sir, this much length is 4. This much length is 4. It is simply a triangle, no? It is simply a triangular structure. This much length is 4. And so what is this much length? This much length is 2. So what will be the area? Area will be half into base is 4. Just look at this triangle. Just look at this triangle. So half into base into height. Right? Half into base into height. So what will be the answer? 4 units square. But this is what we are not supposed to do. What we are supposed to do? We are supposed to find out the area as dx dot dy. And this is how it is written. Okay? Dx dot dy r. What is the r? R is the region bounded. R is region bounded. Region bounded in xy plane. So this is the notation. In the examination, this notation might be used. Region bounded in xy plane. Okay? So in the examination, this notation might be used. So dx dot dy, because I know that I am working on xy plane. In the direction of x, if I work, I will move for dx. In the direction of y, if I move, I will move for dy. So dx dot dy would be written dx dot dy, and double integration I need to take. I need to take the limit of x as well. I need to take the limit of y as well. Okay, and then here I would write down r. I am not writing down the limit. I would write down r. R means that I need to write down the limit in this region r. So this is the notation that is used. This is the notation that is used. It is simply nothing but the notation. So now how will you find out the area? So let's find out the area now. What we would do? We would again make the structure, and method 1. First we will write down method 1. In method 1 we are taking vertical strip. Taking vertical strip. So first of all, let's now this time I will make only the region bounded, nothing else. Only the bounded region I will make. Zero comma 2, 0 comma minus 2, 0 comma 2, 0 comma minus 2, 2 comma 0, and this is the bounded region we have made. Right? Here what is the value of x on this line? The value of on this line, what is the value of y? Value of on this line, the value of y is nothing but 2 minus x. And on this line, what is the value of y? Value of y is x minus 2. Value of y is x minus 2. So here value of y is 2 minus x, and here the value of y is x minus 2, right? So what I would do, I would take a vertical strip in a manner that it should cover the whole boundary. This is the area bounded, no, this is the region bounded, so it should cover the whole boundary. From here to here I will take the limit, complete vertical strip I will take. Like whole boundary means whole region it should cover. Like when I am taking the strip, let's just say someone would have taken the strip in this manner, some would have taken the strip in this manner. Now if you move the strip, if you move this strip, then only this much area it would cover if you move the strip, right? So what we need to do, we need to take the whole scenario, no? Now if I move the strip, this strip will go here as well, this strip will go here as well, right? This will go here as well, this will go here as well, this will go here as well, right? So if you move it completely, you would know that y is going from x minus 2 to 2 minus x. The bottom of this strip is at x minus 2, and the higher point is at 2 minus x. So y is going from x minus 2 to 2 minus x. Say yes or no. This is where y is going. And what about x? So when you move this strip, so x is moving from x equals to 0 to x equals to 2. When you move this strip, x is moving from x equals to 0 to 2. So when you move this strip, x is moving from x equals to 0 to x equals to 2. Now someone would have a doubt that, sir, what if I do someday if I do dx dot dy, this limit of y is also variable and limit of x is also variable, then how will I solve it? This will never happen. Okay, if it is happening, that means you are doing something wrong. Always, let's just say if there are three integral, no, so two limits can be variable, one has to be constant. Okay, if you are making four integral, then three limits can be variable, one has to be constant. If you are doing two integral, one can be variable, one has to be constant. Okay, so both cannot be variables. So y is going from x minus 2 to 2 minus x, and x is going from 0 to 2. X will go from 0 to 2. So what will be the area? Area will be simply, sir, dx dy. First I will write down dy first. Why I am writing down dy? Because I know that, sir, this is the variable limit which is going from x minus 2 to 2 minus x. And then, sir, dx, where x is going from 0 to 2. So if you solve this one, what you will get? If I solve this one, so x going from 0 to 2. If I solve this, I will get x minus 2 to 2 minus x dot dx, x going from 0 to 2, 2 minus x, 2 minus x, and then first I will put the value of y, which is 2 minus x, then I will put the value of y, which is x minus 2, but with then negative sign. So basically this is what I will be doing, no? First I will be putting 2 minus x, then minus x minus 2, right, dot dx. So x going from 0 to 2, so 2 minus x plus 2 dot dx. So 4 minus 2x, so from here area is coming out to be x going from 0 to 2, 4 minus 2x dot dx. So we are getting 4x minus 2x square by 2, which will be x square, x going from 0 to 2. 8 minus 4, answer is 4 unit square. That was the answer. 4 unit square was the answer. 4 unit square is the answer. So this is how we would solve it. But when you take the horizontal strip here, no, then interesting part would come. Take the horizontal strip now. Okay, method 2, take the horizontal strip. Method 2, taking horizontal strip. If you take the horizontal strip, first of all you try on your own. Okay, don't look at the solution. Take horizontal strip and try doing the solution and move the strip. Once you move the strip, you will see something interesting. Take the horizontal strip and move the strip. Once you move the strip, you will surely see something interesting for sure. Bigger diagram. I am just making the area bounded. So this was the area bounded. Okay, this is your y, this is your x. Coordinates we know. Coordinates are 0, 2, 0, minus 2, 2, 0, 2, 0, minus 2, 2, 0. But if I take the horizontal strip, let's just say I have taken a horizontal strip here. This is the horizontal strip I have taken. What is the value of x here? X equals to 0. And what is the value of x here? You can see from this equation, value of x will be nothing but 2 minus y. This is the equation, x plus y equals to 2. So value of x is 2 minus y. So value of x is 2 minus y. So sir, yes, x is going from 0 to 2 minus y. That's it. Is it correct? No, move the strip. No, you have to move the strip. If this strip goes upward till this point, sir, all okay. Till this point, all okay, sir. X is going from 0 to 2 minus y. Here also, sir, all okay. X is going from 0 to 2 minus y. All okay, sir. Just as you come here, x is going from 0 to, what is the equation of this line? The equation of this line has changed. What is the equation of this line? The equation of this line is x minus y equals to 2. That means x is 2 plus y here. So x is going from 0 to 2 plus y. So when you are moving the strip, x is changing the definition. Because there is a break point like this. This is the break point. This is a big break point. Basically, whenever you move the strip, keep on moving. Your target would be that I will move the strip from top to bottom or bottom to top. So when I am moving the strip, coming down, coming down, coming down, coming down, just as I encounter some break point, just as I encounter some transition point, then I have to be aware. That definition of the graph is changing. Here the definition of the graph has become x is going from 2 plus y. X is going from 0 to 2 plus y. So initially x was going from 0 to 2 minus y. And then x started going from 0 to 2 plus y. Now let me know one thing. When x was going from 0 to 2 minus y, in that when you are moving the strip, in this much region, from where to where your y is going? Sir, my y is going from 0 to 2. Y is going from 0 to 2. Always from lower limit to higher limit. When I move the strip in this region, my y goes from 0 to 2. Say yes or no. When I move the strip, this is the strip that I have taken. When I move the strip only in this much region, so y goes from 0 to 2. Say yes or no. And when I move the strip in this region, in which region? In this region when I move the strip. When I move the strip here, where does my y go? In this region if I move my strip, so my y goes from 0 to minus 2. Y goes from 0 to minus 2, or I will write down minus 2 to 0. Why is that so? Because always I need to write down from lower limit to higher limit. So the scenario is y goes from minus 2 to 0, while x goes from 0 to 2 plus y, then y goes from 0 to 2 and x goes from 0 to 2 minus y. This is how you are going to write down your area. So my area would be dx dy with respect to the region R. How will I write it down? I will write down in this manner that sir, y goes from minus 2 to 0, y goes from minus 2 to 0, and x going from y goes from minus 2 to 0, x going from 0 to 2 plus y, x going from 0 to 2 plus y, dot dx dy, because first I will put the limit of x, plus now your y goes from 2 to 0, sorry, y goes from 0 to 2, y goes from 0 to 2, y goes from 0 to 2, but x goes from, what about x? X goes from 0 to 2 minus y, 0 to 2 minus y. Here directly 2 minus y dx dy. Now I need to solve this integration. When I solve this integration, I will get the result. Did you understand the point or not? When I am taking a horizontal strip, I am encountering something very special. What very special I am encountering? When I am taking the horizontal strip, I am encountering something very special. The special thing was that, sir, when I am moving the strip, I am encountering a break point, transition point, whatever you want to call it. But the definition of the graph is changing. X equals to 0 to x equals to 2 minus y, x equals to 0 to x equals to 2 plus y. So definition of the graph is changing. This is what I was encountering. Is that understandable to you or not? So now I am supposed to solve this integration which I need to solve. So what will be the integration? So here y is a constant limit which I will solve later on. First of all, I need to solve this part. So integration of dx would be x, 2 plus y minus 0 would be 2 plus y dot dy. Then integration goes from y goes from 0 to 2. Then this much part I am supposed to solve. So 2 minus y minus 0. So 2 minus y dot dy. Right? Now, when I solve this integration, so 2y plus y square by 2 minus 2 to 0 plus 2y minus y square by 2 0 to 2. Now just put the limit. If you put 0 0, your answer will be 0 0 only. When I put here minus 2, I will get minus 4 with the minus sign, minus 4 plus 2. So this will become 2. When I solve this one, I will get 2. It is up to you how to solve this one. This much you should be able to do. Put 0 here. 0 plus 0 square by 2 will be 0 only. Minus 2 into minus 2 will be minus 4. Plus 2 into 2 will be 4. 4 divided by 2 would be plus 2. So minus 4 plus 2 will be minus 2. Then another minus sign was there, so it will become plus 2. Plus put 2 here. 4 minus 2 will be 2 only. So answer is coming out to be 4 units square. That's it. This is the answer. So I hope you have understood how to take the strip. So I will, in the examination hall, I will be aware. No, I will see if I am taking the horizontal strip, then definition is changing. Then I will not solve by horizontal strip. I will solve by vertical strip, because vertical strip would be easier for me. I need to solve only one integration. So that I have to be aware. So if you solve good enough example by taking both of the strip, then you will be able to understand that which integration you need to solve in the examination hall. Is that clear to you? Okay. Yeah. Another thing you can see here. So sir, when I solve this particular integration, what scenario I was getting? This scenario I was getting. This scenario I was getting. Right? So isn't it some limit x going from a to b? Isn't it a function of x? Fx dot dx. See yes or no? What it is representing? Eventually it is representing the area. So when I said in the last lecture, limit x going from a to b, fx dot dx represents the area. Single integration, limit x going from a to b, fx dot dx represents the area. This is what I said. Here what I said, single integration is representing the length. Single integration is representing the length, but there is no function of x, there is no function of y, there is no function of z, there is no function of variable. Directly dx is there. That's why it would represent the length. But if I say single integration fx dot dx, single integration fx dot dx, limit x going from a to b, what it would represent? It would represent the area. So why it represents the area? Is it clear to you or not? So if someone ever comes and say that single integration represents the length, double integration represents the area, triple integration represents the volume, then tell to him, good knowledge, very good. Now don't come to me with your knowledge. Okay, this is what you have to say, and your knowledge is clear, your concept is absolutely clear that what it represents. Understandable? So answer is 4 unit square here. If you solve this one, here also answer is 4 unit square. All good. Let's solve the next one. What you need to determine? Determine the area of the region in xy plane bounded by the curve y equals to x square and y equals to x. So y equals to x square we need to make, and y equals to x we need to make. And bounded region. What will be the bounded region? Y equals to x square. Can I make y equals to x square? Yes sir, y equals to x square will look somewhat like this. At least 20-30 times we have made this graph. Y equals to x square. This is the graph of y equals to x square. Then can I draw the graph of y equals to x? Absolutely. This is the graph of y equals to x. This is the graph of y equals to x. Y equals to x square I will write down here. And this is the graph of y equals to x. What is the area bounded? So how much area it is bounding? This much area it is bounding. What is the area bounded? This much area is the bounded area. So this much area we are supposed to find out. We are moving in the direction of x and y. So what I will write down? The area would be dx dot dy in the region R. So can I take the region R? What I will do? I will take the Method 1, method 2, again method 1, what I am doing, vertical strip. So when I take the vertical strip, this is how I will take the vertical strip. If I move the strip from the bottom, right from here to till this point, if I move the strip, take the strip here as well. No matter wherever you take the strip, if you move the strip, are you encountering the breakpoint anywhere? Are you encountering the transition point anywhere? Anywhere are you encountering? No. Everywhere the definition is going from always top to bottom. Always, how will you write down? Top to bottom. Y is going from x square to x. Y is going from x square. This is y equals to x square and this is y equals to x. So y is always going from x square to x. And from where to where x is going? So I need to find out this point. What will be this point? Simply I need to find out where both of the curves are cutting. Y equals to x square, where they cut each other. So for that, what I need to do? Y equals to x square here, y equals to x here. From here, what I would get to know that x square equals to x. That means x square minus x equals to 0. So from here, the value of x is coming out to be 0 and 1. So they will cut each other at x equals to 0. If x is 0, then y will also be 0. If x is 1, then y will also be 1. So they are cutting each other at 1, 1 and 0, 0. So this point is x equals to 0. Sorry, x equals to 1 and y equals to 0. So when you move this strip, when you are moving this strip, so y is going from x square to x, but x is going from 0 to 1. So this is how x is, from where to where x is going. So I need to see in the direction of x, no, in the direction of x. X is going from 0 to 1. Y is going from x square to x. Y is going from x square to x, but x is going from 0 to 1. When I have taken the limit of y, my job is left for x now. So forget about y now. Forget about y. In this whole structure, how much my x is moving? X is going from x equals to 0 to x equals to 1. Here the value of x is 1. Is that clear to you? Similar thing here also you can do. So when I have taken the limit of x, forget about x now, just talk about the y now. So how y is moving? Y is moving from 0 to 2. When I have taken the limit of x, forget about x now, only talk about y now. How y is moving? Minus 2 to 0. Similar scenario here as well. When I have taken the limit of y, forget about y now, talk about the limit of x. X is moving from 0 to 2. Understandable? Similar scenario here as well. When I have taken the limit of y, forget about the limit of y, talk about the limit of x. X is moving from 0 to 2. That's it. This is how the scenario would go on. So if I have taken the limit of y, which is going from x square to x, I will forget about y now, I will only talk about x now. So x is moving from 0 to 1. X is moving from 0 to 1. So x is moving from 0 to 1. That's it. Is that clear to you? Y is moving from x square to x. This bottom is y equals to x square and this top is y equals to x. So y is moving from x square to x. Forget about y now. X will be moving from 0 to 1. In this whole scenario, in this whole region, x is moving from 0 to 1. That's it. So what will be your area? Area will be always constant limit in the last and variable limit before dy dx. So when you solve this dy, what answer you will be getting? X going from 0 to 1. Integration of dy will be y. Then you need to put the limit, which is x minus x square dot dx. So what you are getting? X square by 2 minus x cube by 3, x going from 0 to 1. So if you put the limit 1 by 2 minus 1 by 3, that would be 1 by 6. 1 by 6 unit square would be the answer. That's it. Okay, here also you can see fx dot dx, x going from a to b. What it is representing? It is representing the area. 1 by 6 unit square, that would be the answer. Method 2 could also be there, taking the horizontal strip. Method 2, taking horizontal strip. Only the shaded area I am making, okay? Only the shaded area I am making. So this point is 0, 0 and This point is 1, 1. Right? And what is the equation of this graph? Y equals to x. What is the equation of this graph? Y equals to x square, or why I'm not writing down the equation as of now. Let's first take the strip. So strip, I will take a horizontal strip this time. Horizontal strip this time. If you move the strip from here to here, you move. Is the definition changing? Absolutely not, sir. If you move from here to here, definition is changing? No. So what is the value of x here? The value of x is y. And what is the value of x here? So y square equals to x, was the x equals to y square equals to x, or y equals to x square was the scenario, no? Y equals to x square. So what is the value of x? So someone would say, sir, x would be equals to plus minus under root y. But here positive value is there, no? Right? In this region, x is positive, no? X is positive. X is positive. So what I need to take? X equals to under root y. X will be negative here. X will be negative here. So I would have taken x equals to minus under root y. But here x is positive, no? So I will have to take x equals to plus under root y. Understandable? So x is always going from y to under root y. Once I have taken the limit of x, x is going from y to under root y. When you move left to right, top to bottom, down to up, left to right. So y to under root y. Lower limit to higher limit. Here the value of x is lower, here the value of x is higher. So lower to higher, y to under root y. And if I would have taken the limit of y, when I was taking the limit of y, I was going from lower to higher. That means x square to x, left to right, lower to higher. Understandable? And what is the limit of y? When you have taken the limit of x, forget about x, only talk about y now. So y is going from 0 to 1. Or what you can think, how you can think. Look, when I have taken the limit of x, I need to talk about the limit of y, which will be a constant limit. So what you need to do is that you need to take the projection of this particular structure on y-axis. Basically, take this structure and squeeze it on y-axis. Take this structure from here. From here you take this structure and squeeze it on y-axis. If you take this structure and squeeze it on y-axis, then what kind of structure you will be getting? If I squeeze it on y-axis, then squeeze this one as well. If you squeeze this one as well now. So if you squeeze this one, then this kind of structure you will be getting. So in this structure, y is going from 0 to 1. Are you able to understand this point? Like, it is very easy. Here it is very straightforward. You know that, sir, limit of x we have taken, value of y is going from 0 to 1 only. Here I can directly see the value of y is going from 0 to 1. But if there is some complex structure where you are getting confused, then what you can do is that whatever the structure is there, whatever the graph is there, squeeze it on y-axis. If you squeeze it on y-axis, you would know that y will go from 0 to 1. Y will go from 0 to 1. Similar thing you can do with x-axis as well. That when I have taken the limit of y, now I need to take the limit of x. So what you do, you squeeze this particular structure on x-axis. So when I squeeze this particular structure on x-axis, or you can say I am taking the projection of this structure here if there is a sun. So if I take the projection of this structure on x-axis, what I will see? The x will go from, what I would see, the x would go from 0 to 1. If I squeeze this downward, the x would go from 0 to 1. If I take a projection from here, if I squeeze this downward, x would go from 0 to 1. Is that understandable to you or not? Similarly, if I squeeze this on y-axis, then y would go from 0 to 1 after taking the variable limit. After taking the variable limit, taking the constant limit would be very easy for you. Is that clear to you? Other scenario as well you can do. Here, which limit we have taken? We have taken the limit of x-axis, right? We have taken the limit of x. Now I need to take the limit of y. So the whole structure, here I will put the sun, here I will put the sun, and I will take the projection. So squeeze it on y-axis completely. Squeeze it on y-axis completely. So if I squeeze this particular structure on y-axis completely, I would say that y is going from -2 to 2. So for this much scenario, it would be from -2 to 0, and then for the other scenario, it would be from 0 to 2. Is that clear to you? So this kind of scenario we need to do. Is that clear? In other example as well, you can check this particular scenario. Everywhere it would be working. Okay. Yeah, so solve this one now. So what we will do, area, x is going from y to under root y dot dx, and then dy, y goes from 0 to 1. So when you solve this integral, what it will give you? It will give you under root y minus y dot dy with y going from 0 to 1. Y going from 0 to 1. So what will be the integration? Y to the power 3 by 2 divided by 2 by 3 minus y square by 2. Y going from 0 to 1. So 2 by 3 minus 1 by 2. 4 minus 3, that is 1 by 6 unit square. So 1 by 6 unit square is the answer. In both of the cases, we were getting the same answer. We are getting the same answer. Understandable? Very easy question, very straightforward. Okay, these kind of questions are very easy. Let's go to the next one. Determine the area in the region in the xy plane bounded by the curve y equals to minus x square plus 4, y equals to x square. So will you be able to draw the graph? Absolutely, sir. Y equals to x square I can draw, and y equals to minus x square plus 4 also I can draw. Y equals to x square. Y equals to x square. So making all these graphs I have already taught you. So y equals to x square. This is your y equals to x square. Next I need to make minus x square plus 4. Minus x square plus 4. That means minus x square plus 4. Minus x square plus 4. This will be the graph. At x equals to 0, the value will be 4. At x equals to 0, the value will be 4. This is 0, 0 only. Now I need to find out the points where they are cutting. So one graph is saying y equals to x square. Other graph is saying y equals to minus x square plus 4. Where they are cutting, so both of them you can equate. Here the value of y is x square, here the value of y is minus x square plus 4. So y equals to minus x square plus 4. So 2x square would be equals to 4. So x is coming out to be plus minus under root 2. So if x is plus minus under root 2, here you put plus minus under root 2. So value of y will come out to be 2 only. So value of x is minus under root 2 and value of y is 2. And value of x is under root 2, value of y is 2. So this is the bounded region. This is the bounded region. This is the bounded region. Right? What we are supposed to find out? We are supposed to find out the area. What I would do? So dx dy. Method 1, method 2. Right? Taking vertical strip. Vertical strip seems very easy for me here. Why is that so? Because if I move the strip anywhere, this is the strip I am taking. You move the strip here. Are you encountering, if you move the strip, are you encountering any breakpoint? No, no breakpoint I am encountering. Move the strip, try moving the strip. Here you move it, here you move. No breakpoint you are encountering. Everywhere the definition is same. Everywhere the definition is same. You can check the definition. Everywhere the definition is same. What the definition is saying? That y is going from, this is your y is going from downward, it is x square. Y is going from x square to, and this graph is nothing but minus x square plus 4. This graph is y equals to minus x square plus 4. So y is going from x square to minus x square plus 4. Right? Y is going from x square to, this is your x square, from x square to minus x square plus 4. Right? And from where to where x is going. If you have taken the limit of y, forget about y, just squeeze this structure. Just squeeze this structure. Forget about all other structure now. Forget about all other structure. Just squeeze this structure on x-axis. I need to take the limit of x-axis, you know. So what will be the value of x here? The value of x here is minus under root 2, 0. And what will be the value of x here? Under root 2, 0. So value of x will go from minus under root 2 to plus under root 2. Okay. So what will be the area I will write down? So area would be written in this manner, that value of x is going from minus under root 2 to plus under root 2, and the value of y goes from x square to minus x square plus 4. This is your dy dot dx. Right? So x is going from minus under root 2 to plus under root 2 minus x square to minus x square plus 4. Minus x square, sorry, from x square to minus x square plus 4. So it will give you minus x square plus 4 minus x square, right? So dy will give you the integration of y, so it would go minus x square plus 4 minus x square dot dx, right? So what will be the area? Area is x going from minus under root 2 to plus under root 2 minus under root 2 to plus under root 2 minus 2x square plus 4 dot dx, minus 2x square plus 4 dot dx. So what will be the answer you will be getting? By 3 plus 4x. Put the limit from minus under root 2 to plus under root 2. Now put the limit minus 2, so 2 under root 2 with the negative sign, this will become plus, divided by 3. Okay, I am putting the plus limit, no, sorry. First I will put the plus limit. So minus 2 into 2 under root 2 divided by 3 plus 4 under root 2 minus 2, and then under root 2 cube would be 2 under root 2 with the negative sign divided by 3 minus 4 under root 2. Did you understand putting the limit? I am just putting the limit here. If I put under root 2 here, this will become 2 under root 2. So 2 under root 2 minus 2 under root 2 divided by 3 plus 4 under root 2 minus sign. Then already there is a minus sign, and minus under root 2 cube would become minus 2 under root 2. So this would become plus 4 under root 2, right? Plus 4 under root 2 it would become, divided by 3 minus 4 under root 2. So answer is minus 4 under root 2 divided by 3 plus 4 under root 2 minus 4 under root 2 divided by 3 plus 4 under root 2. So what you are getting? 2 into 4 under root 2, that would become 8 under root 2 minus 2 into 8 under root 2 divided by 3. So this will become 2 by 3 of 8 under root 2. So 16 by 3 under root 2 will be the answer. 16 by 3 under root 2 will be the answer. 16 by 3 under root 2 unit square will be the answer. Hopefully this is correct. Here the answer is written 1, 2, 3. 16 by 3 under root 2 is the answer. Okay, that's the answer. Taking the vertical strip. Now take the horizontal strip. Do it on your own. Okay, I will take a break. This was the method 1. Take the horizontal strip. You can directly see that, sir, if I take the horizontal strip, definition would change. Right? Here the definition is going like this. If I take it downward, definition would change because I would encounter a transition point. So definition will surely change. So take the horizontal strip. Make a bigger diagram. Okay, make a bigger diagram so that you would be able to see in a good manner. Okay, so method 2, you do it on your own. I will take a break and then I will come back. Okay. Yeah, welcome back. So I have made the shaded region. Okay, so this was the shaded region. This was the this much region I have made. Okay, this region I have already made. So this region I have made, and these points also I have made. This point was where they were cutting. Two graphs were there. What was the equation of this line? The equation of this line was y equals to minus x square plus 4, and the equation of this line was y equals to x square. Right? Now what I am supposed to take? I am supposed to take the horizontal strip. Let's just say I would have taken the horizontal strip here. So if I would have taken the horizontal strip here, when I move it till this point, it was fine, sir. If you move till this point, sir, it is fine. But just as the strip comes downward, the definition changes. Right? Why is that so? Because, sir, you are encountering the transition points. You are encountering these transition points as the strip moves. Now on this curve, what will be the value of x here? What will be the value of x here? So what is the equation? Y equals to minus x square plus 4. This is the equation. Y equals to minus x square plus 4. Y equals to minus x square plus 4. So that means x square is nothing but 4 minus y. So x value is plus minus under root 4 minus y. So value of x is going from minus under root 4 minus y to, because value of x is negative here, no? Value of x is negative here. So value of x is going from minus under root 4 minus y to plus under root 4 minus y. So this is your minus under root 4 minus y to plus under root 4 minus y plus under root 4 minus y. And from where to where value of y is going? in this whole region till this point. No, we are taking the strip in this much region. We are taking the strip in this much region. In this much region, we are taking the strip. So from where to where y is going? Y is going from 2 to 4. Y is going from 2 to 4. What you do? You take the projection. Take the projection on y axis. Take the projection on y axis. Take the projection from here. So just squeeze this structure on y axis. So value of y is going from 2 to 4. Understandable? So value of y is going from 2 to 4. So this is the first region that we have find out. This is the first region that we have find out. First region. Okay. There would be other region as well. What is the other region? Other region is this. So here y equals to x square. That means value of x is going from minus under root y to plus under root y. Value of x is going from minus under root y to plus under root y. And what about the value of y? Y is going from, if you just squeeze it, y is going from 0 to 2. Y is going from 0 to 2. There you go. This will be your surface area. Okay, like let's just say in the examination you would have made this diagram. So in this diagram only you would be taking the horizontal strip, then it would be very difficult to do the calculation. Like here we are very easily able to do the calculation. First of all, we are not sitting in the examination hall. Second of all, we have made a very clear diagram. Then we can see all the points. This is 0, 2. So y is going from 2 to 4, 0 to 2, x is going in this manner. So very clear things are there. But in the examination hall, very small page would be there. In that small page, things may go very difficult, right? So that's why I would always say that always choose the strip in a manner that minimum calculation is there. So if I choose the strip in this manner, minimum calculation would be there. Horizontal strip I will choose. I just will make sure one thing, that there is no transition point. So if I move the strip, there is no transition point. That's why I will choose horizontal strip only. This is just for your practice purpose. Sorry, I will choose vertical strip only. This is horizontal strip is just for your practice purpose, that you can do the practice. For sure, we should do the practice at home. But in the examination, we will choose the best possible strip, right? So y is going from 0 to 2. Y is going from 0 to 2 with x going from minus under root y to minus under root y to plus under root y dx dy plus y going from 2 to 4 with x going from minus 4 minus y to plus under root 4 minus y. I should have written, sorry, x is going, no, x, this is x, this is your x, dx dy, right? So what you will be getting? So here if I solve it, y going from 0 to 2, 2 under root y dot dy plus y going from 2 to 4, 2 under root 4 minus y dot dy, right? Integration of dx would be x, then under root 4 minus y minus under root 4 minus y, so 2 under root 4 minus y dot dy. This is what we will be putting, right? So if you just solve it, what answer you will be getting? You just need to solve it, and what answer you will get. For that, here we will do the calculation. So 2 is common. Y to the power 3 by 2 divided by 3 by 2. 0 to 2 plus 2 here, 4 minus y to the power 4 minus y to the power 3 by 2 divided by 3 by 2, and then there is a negative sign, and y going from 2 to 4, 2 to 4. Look, integration is also not that straightforward. First of all, taking the limit was difficult, and now the integration is also not that straightforward. So here if you put 2 to the power 3 by 2 would be nothing but 2 under root 2 minus 4 by 3. If you put 4 here, answer will be 0. If you put 2 here, 2 under root 2 would be there. So this will come out to be 4 by 3 into 2 under root 2, and then it will become twice of it, because minus sign goes outward, it will become plus. So multiply with 2. So answer is coming out to be 16 by 3 under root 2. Same answer we are getting. Just the integration is also a bit complex. Along with that, taking the horizontal strip was also a bit complex, right? So what we will do, if this question was coming in the examination hall, I would have taken the vertical strip, not the horizontal strip. Understandable? But using the horizontal strip, this is how I would have solved the problem. Understandable? Well and good. Let's go to the next one. Determine the area of the region enclosed by the curves y equals to x cube minus x square minus x plus 1 and y equals to x square minus 1 between x going from minus 1 to 1. So here I am asking you the question of application of derivative as well, and along with that I am asking you the question of integration as well, because you will have to draw this curve. No, you have to draw this curve. You will have to draw this curve. So first of all, our target is to draw this curve. This curve we can draw. X square minus 1 is very simple, right? X square minus 1. So x square minus 1 will be like this. It is very simple. But how this curve will look like, that is our target. So for drawing the curve, what we need to do? We need to differentiate this, and our target is, first we need to draw the curve. This we need to draw. This we need to draw. So for that we need to differentiate and then put that equals to 0. So 3x square minus 2x plus 1, put that equals to 0, right? So 3x square minus 3x प्लस x प्लस क्या कर रहा हूँ भाई मैं, 3x square minus 2x minus 1, right? This is minus 1, no? 3x square minus 2x minus 1. Yeah, so 3x square minus 3x plus x minus 1 equals to 0. 3x into x minus 1 plus 1 x minus 1 equals to 0. So from here minus 1 by 3 and 1. So let's talk about the slope. Minus 1 by 3 and 1. So after 1 the slope is positive, negative and positive. The slope would go like this, increasing, then decreasing and then increasing. So this is how the nature of graph would go. But we need to find out the values. So at y equals to 1, what will be the value? What will be the value at y equals to 1? So the value at y equals to 1, which will be the minimum value? No, this will be the minimum value. So value at y equals to 1 will be nothing but, if you put 1 here, so 1 minus 1 will be 0. Value at y equals to 1 is actually 0. The minimum value is 0. So how the graph would go? Can you draw the graph now? At 1 by 3, I don't need to find out the value. Okay, whatever the value I will get, now I can draw the graph. And my matter of concern would be between minus 1 to 1 only, but I can draw the complete graph as well. And where the graph would become 0, where y would become 0. This y would become 0 at what points? That also I can find out, right? At what points this y would become 0, that also I can find out, no? So what I am doing, at what points y would become 0, that I am finding out. How to draw the graph, that we have already studied. So you should not be much getting confused that what we are doing here. So when y would become 0, when these things become 0. So at x equals to 1 it will become 0. So I know that x minus 1 will be one of the factors. So here x square, this will become x cube. Then so x cube minus x square, x cube minus x square, so 0, and then plus 1 you would need. This is the scenario. 2, yes. So x plus 1, x minus 1. So from here x equals to 1 and minus 1. If you put minus 1 here, you will get minus 1, plus 1, plus 1. So 2 minus 2, 0. Yes, only 2 points are there where y would become 0, that is plus 1 and minus 1. So basically this point would have been minus 1. This point would have been minus 1. Okay. So at minus 1 you will get 0 value. At minus 1 by 3 you will get maxima. At x equals to 0 the value will be 1. You can find out the value of y at x equals to 0, the value will be 1 only. So here at x equals to 0 the value will be 1. At x equals to 1 the graph will be minima and the value will be 0. So this is how the graph would be going. Will be attaining the maximum value, then it would attain the value 1, then it would attain the minimum value, and after that this is what it will, this is how the graph would go, right? This is how the graph would go. Understandable? Now I need to draw the graph of x square minus 1. X square minus 1, you would know that this graph would become 0 at x equals to plus minus 1. So x square minus 1, the graph would look somewhat like this. X square minus 1, the graph would look somewhat like this. This is how the graph would look. They may cut again, but my matter of concern is, like, what I mean to say is that, sir, these two graphs are going till infinity, no? So they may cut again. Somewhere they can cut. But I don't care about it. Why is that so? Because they are asking between -1 to 1 only. They are asking between -1 to 1. That means they are asking only this much region. That's it. They are asking only this much region. This is the region that they are asking between -1 to 1. Because it is specifically mentioned that you need to find out between -1 to 1. Now they may cut again. Where both of the graphs will be cutting, that point I don't even need to find out. Why I don't even need to find out? Because they are asking the area enclosed between -1 to 1 only. So this will be that region. Now this -1/3 is not a matter of concern, so I will remove it. This also I will remove. So this is the region that they are asking. Okay. So what do you think, which strip will you take? What do you think, which strip will you take? If I take the horizontal strip, what will happen? Sir, horizontal strip, if you move, so here it is fine, but sir, here the definition would change. Horizontal strip will change the definition. So better, let's take the vertical strip only. Let's take the vertical strip only, because in the vertical strip, if you move it, always the definition would remain the same only. What will be the definition? What will be the definition if you take the vertical strip? In the vertical strip, sir, downward the definition is y equals to x square minus 1. And on the upper side, sir, here the definition is x cube minus x square minus x plus 1. And then you take the integration, limit of y is going from, always you take, anywhere you take the horizontal strip, anywhere you take the strip. Here also you take the strip, the same definition would be there. Here you take the strip, the same definition would be there. Everywhere the definition would be same. Everywhere the definition would be same. Everywhere the definition would be same only. So y is going from x square minus 1 to x cube minus x square minus x plus 1. Minus x plus 1. And x is going from, if you have taken the limit of y, then what you do, you take the sun here, you take the sun here as well, then squeeze it. If you squeeze it, you would surely understand that x is going from -1 to 1. Directly you can see x is going from -1 to 1. There you go. This is the integration you need to do now. So what will be the area? X going from -1 to 1, x going from -1 to 1, the value of y going from x square minus 1 to x square minus 1 to x cube minus x square minus x plus 1. Is that correct? X cube minus x square minus x plus 1 dot dy and then dot dx. Right? So when you solve dot dy, x going from -1 to 1, x going from -1 to 1. When you solve dy, what you get? X cube minus x square minus x plus 1 minus x square plus 1 dot dx. So x going from -1 to 1, x cube minus x square will become -2x square. This is minus x plus 2 dot dx. So x to the power 4 by 4 minus 2x to the power 3 by 3 minus x square by 2 plus 2x. X going from -1 to 1. 1 by 4 minus 2 by 3 minus 1 by 2 plus 2 minus 1 by 4 plus 2 by 3 minus 1 by 2 minus 2. 1 by 4 minus 1 by 4 will be gone, minus 2 by 3 minus 1 by 2 plus 2 minus 2 by 3 plus 1 by 2 plus 2. So this and this will get cancelled out. 2 plus 2 4, 4 minus 4 by 3, 4 minus 4 by 3, 8 by 3 is the answer. 8 by 3 is the answer. That's it. This is the answer. So answer is 8 by 3. Can we check? Yes, answer is 8 by 3. So simply just take the strip and your job will be done. Here this question was good because two things we were asking here. And secondly, if they did not mention -1 to 1, then this question would have become very good actually. Why is that so? Because they would cut. Like this graph is not ideal graph. No, they can cut at some other point as well. That I don't need to find out although. So let's just say the graph was going like this. Let's just say the graph was going like this. Let's just say the graph goes like this. This is how the graph was going. So they may cut at some other point as well. No. So this could also be the region bounded. Are you able to understand this point? So if they are asking the region bounded, then this region we would find out, and along with that this region also we would find out, and both of the answer we would add. Right? Are you able to understand this point? So yes or no? But they are asking between -1 to 1, so this question has become a bit simpler. But if they were asking about the whole area bounded, like they did not mention -1 to 1, only the question was determine the area of the region enclosed by the curves. That's it. This was the question. Till this point the question was there. So then what I would have done, I would add a page. If we are doing the discussion, then let's do it completely only. So what I would have done is that let's take this question and अरे भाई ये क्या कर दिया मैंने. Let's take this question, paste it here, and this time what I am doing is that I am removing this much part. So what I would have to do is that I would have to find out that at what point they are cutting each other. So y equals to this is given and y equals to this is also given. So at what point they are cutting each other? Where both are equal, right? So what you are getting, x cube minus 2x square minus x plus 2, right? So from here you can take x square common, so x minus 2 minus 1 x minus 2 equals to 0. So x plus 1 into x minus 1 into x minus 2 equals to 0. So value of x is -1 plus 1 and 2. These are the values of x. There they are cutting. So at -1 and +1 they are cutting, that we already know. At -1 and +1 they are cutting, that we already know. So what I would have done is that I would simply copy this graph, or let's make the graph again. Why we need to copy? Let's make the graph again. First I am making the graph of x square minus 1. Okay, so this point is -1, this point is +1, and this is how the graph would go. This is how the other graph was going on. Here you would get the minima. Look, again, not a very good way of looking at the graph. Like, you would have understood my point. I am pretty sure you have understood the point. Wait a second. I need to make the graph. I will make it by hand now because no other option left. I have to make by hand only. Okay, so this is the graph of y equals to, this point is -1, this point is 1. Next, this is how it will start. At here it will get the maxima. So this is how it will start, get the maxima, then comes downward, get the minima, and then goes upward. And here they cut again. Okay, so this is the point where they are cutting again. Here they cut again. Okay, well and good. So what will be the region bounded? This will also be the region bounded. No, this will also be the region bounded. So this region bounded we have already find out. This region bounded we have already find out. That came out to be 8 by 3. But this is your x equals to 2. At x equals to 2, what value you are getting? 3 value you are getting. Value you are getting is 3. So you take the horizontal strip, you take the vertical strip, doesn't matter. Take the horizontal strip or take the vertical strip, doesn't matter. At both of the places the definition is not changing. So let's take the vertical strip only. Let's take the vertical strip only. Okay. So what is this area? This area is 8 by 3. This area is 8 by 3. 8 by 3 unit square is the area. And now here the graph is going. Look, if you take the vertical strip here, if you look closely, this graph, this particular graph that we have drawn, that is the lower bound, right? This particular graph and this particular this graph is y equals to x square, and the downward graph is y equals to x cube minus x square minus x plus 1. So here the value of y is going from x cube minus x square minus x plus 1 to x square. And what about the value of x? X is going from 1 to 2. X is going from 1 to 2. Then you will have to solve it and you will get the answer. So x going from 1 to 2 and y going from x square to x cube minus x square minus x plus 1 dot dy dx. So some area A you will be getting. Let's just say some area A you will be getting. So total bounded region. Some area A you will be getting. You can do it on your own. Okay, someone would do the calculation and write down the answer in the comment section. Some area A you would be getting. Then total bounded area. Then what will be the final answer? Total bounded area. Total bounded area would be nothing but 8 by 3 8 by 3 plus A. 8 by 3 plus A. So when you solve this integration, some area A you would get 8 by 3 plus A would be the answer. So someone would write down this answer in the comment section. And if 2-3 people are writing down the answer, then I would get to know that, yeah, this is the same answer they would be getting. So I don't know what is the answer as of now. You can solve it on your own and you will get the answer. Understandable? Very simple integration. You can do the integration and you will get the answer, and this will be the total bounded area. But although in the examination they are only asking between -1 to 1, so it would be an easier question. If they want to make it tougher, then they will not mention -1 to 1, and they would also try to think that if the people are thinking that they are cutting at 2 points, if they are cutting at 2 points, so this also you find out, this also you find out. Although it will become a lengthy question, but it would be a good question. Understandable? Let's go to the next one. Determine the area of the region R in xy plane defined by the x square plus y square less than equals to 4. Can you draw this region? X square plus y square less than 4? Absolutely, sir. You have taught us how to draw these region. Sir, first of all, I need to draw x square plus y square equals to 4. First of all, I need to draw x square plus y square equals to 4. So, sir, first of all, I will draw this one. X square plus y square equals to 4, I will draw. There you go, sir. And then I need to put the point 0, 0. I will put the point 0, 0 here, 0, 0 here. So 0 plus 0 less than 4. Is it true? Yes. That means this will be the region they are asking. Right? So what will be this point? Radius is 2. Right? What is the radius here? X square plus y square equals to 2 square. So what is the radius? Radius is 2. So x equals to 2, y equals to 0. X equals to minus 2, y equals to 0. X equals to 0, y equals to 2. X equals to 0, y equals to minus 2. Understandable? So this is the scenario. What we are supposed to find out? We are supposed to find out the area enclosed. That means this much area we are supposed to find out. So do we know this area? Absolutely, sir. Method 1. I already know this area. This is pi r square. Area of the circle. What is the answer? Pi r square. What is the value of r here? 2 square. What is the answer? 4 pi unit square is the answer. That's it. This is the answer. But let's take the help of calculus. Method 2. If I take the help of calculus, what I would do? Take a strip. Let's take a horizontal strip. Vertical strip also you can take. Sorry. Let's take a vertical strip. Horizontal strip also you can take. If I take the vertical strip, this will be the vertical strip that I am taking. If you keep on moving this strip, anywhere you keep on moving this strip, anywhere you keep on moving this strip. So what will be the value of y? Value of y, this is the circle, no? X square plus y square equals to 4. So value of y is going from under root 4 minus x square to basically x square plus y square. On this curve, I just need to find out what is the value of y here. I need to find out what is the value of y here. So what is the equation of this curve? X square plus y square equals to 4. So y square is going from 4 minus x square. So y is plus minus under root 4 minus x square. So here the value of y is negative, here the value of y is positive. What does that mean? Y is going from minus under root 4 minus x square to plus under root 4 minus x square. And since you have taken the limit of y, what you do? You squeeze this on x-axis. If I squeeze this on x-axis, I would know that x is going from minus 2 to 2. X is going from minus 2 to 2. Right? So what will be the area? Area is dx dot dy. X is going from minus 2 to 2 and y is going from minus under root 4 minus x square under root 4 minus x square. So this is how y is going dot dx. X is going from minus 2 to 2. X is going from minus 2 to 2. So if you solve it, x going from minus 2 to 2 dy, that would become under root 4 minus x square minus under root 4 minus x square. So this will become 2 into under root 4 minus x square dot dx. So what is the answer you are getting? X going from minus 2 to 2 under root 4 minus x square dot dx. Now you would be saying that, sir, you cheated us. You told us not to remember the formula of under root a square minus x square, and now you are asking that solve this integration. Sir, how do I solve now? Sir, first of all, you said that don't remember the formula of what? Under root a square minus x square. Like I told you, no, we don't need to remember in engineering, we don't need to remember this formula. And now you are asking us to solve. You can solve it by what? By substitution. By substituting. By substituting, you can solve. What will be your area? Area is coming out to be 2 into x going from minus 2 to 2 under root 4 minus x square dot dx. 4 minus x square dot dx. First of all, you let me know limit is from minus a to a. Limit is from minus a to a. Is it a even function? Yes, sir. In place of x, if I put minus x, I will get the same function only. So I can reduce it to 0 to 2 under root 4 minus x square dot dx. This is how I can reduce. Right? Right? Now by substituting, you can solve this question. Your target is to solve this integration. Let's just say this integration is I. My target is to solve this integration I. I is 0 to 2. This I am assuming as I. 0 to 2 under root 4 minus x square dot dx. What I would do? I will assume x as 2 sin theta. X will be 2 sin theta. So what will be dx? Dx will come out to be 2 sin theta cos theta d theta. Now x equals to 0, so theta will also be 0. When x is 0, when x equals to 0, then theta will also be equals to 0. And when x equals to 2, then theta will be equals to pi by 2. Right? So from 0 to pi by 2 under root 4 minus x square, that is 4 sin square theta. What is the value of dx? Dx is simply coming out to be 2 sin theta cos theta d theta. Right? So 0 to pi by 2. Positive value we will take, although under root x square is mod of x, but here it would come out to be as 4 into 1 minus sin square theta would be 4 cos square theta, so that would come out to be 2 cos theta. So 2 into 2 will become 4 cos square theta sin theta d theta. This is the scenario that we are getting. Understandable? Well and good. I hope you have understood what I have done here. Right? So 4 into, what is the solution of this? Solution of this will be, so 3 into something wrong we are doing. Right? Substitution is correct or not? 4 sin square theta cos square theta cos theta into 2 sin theta dx is 2 sin theta cos theta d theta. 4 into pi by 3 we are not getting, pi only we are getting. So let me check the calculation again. From minus 2 to 2 we are putting minus 2 to 2, x going from minus 2 to 2. This will become dy, y will become 2 into 4 minus x square dot dx, x going from minus 2 to 2. This is what we are doing. 4 into 0 to 2, x going from 4 into 0 to 2, 4 minus x square, x equals to 2 sin theta I have put. Why 2 sin theta I have put? That is understandable because 4 minus 4 sin square theta I wanted to make. So dx would be 2 sin theta, in differentiation of sin theta would be cos theta, 2 sin theta cos theta d theta, and x equals to 0, so theta would be equals to 0, x equals to 2, so theta would be equals to pi by 2. So 0 to pi by 2, the root, this would become 2 cos square theta, so 2 cos square theta would become 2 cos square theta, so that would come out to be 4 sin square, 4 cos square theta, so 2 cos theta, so 2 into 2, 4 cos square theta sin theta. I am not finding any mistakes, so but the problem is there, no? If I solve it, I will not get the correct answer. Let's solve it. So 2 plus 1 is 3. 3 into 2, 1. Then 2 minus 1 will be 1 only. Here only 1 I will be getting. So answer here I am getting is 4 by 3. So integration I is 4 by 3. So answer is coming out to be 16 by 3, which is wrong. But actually the answer is pi r square. So something wrong I am doing. I need to check the calculation. Okay. Let me pause the video and check the calculation. Yeah. So did you find the mistake? Complete brain fade, right? Dx equals to x equals to 2 sin theta, dx equals to 2 sin theta cos theta. Complete brain fade. Right? If these kind of things happen, then no one can help you in the examination hall. That's why I always say that your teacher might be getting very good score in the examination hall. It is not that straightforward because your teacher may also do these kind of minor mistakes. Right? So here what you will get 2 cos square theta d theta. Right? So this kind of minor mistake I am doing. And if you have studied all the core subjects from me, then you would understand all the engineering subjects from me. EC electrical students would know that I do these kind of minor mistake a lot of times. Basically, whenever I take any question, no. So first, how do I take the question? I take the help of standard books. In standard books, the question would be written in a manner that it is theoretical, but I need to make it exam oriented. So then, with the help of AI tools like ChatGPT, Gemini Pro, I make them exam oriented. Then I put them here. Then I will simply ask them to solve it, and whatever the answer is there, I would write down the answer there. I don't solve it on my own. I solve it with respect to you only. Like when I'm solving it for the first time along with you, so that it feels like that in the examination hall I would be solving in this manner, right? So that's what I do, and you can see what kind of minor mistake I end up doing. So here when I solve it, what I would get divided by 2. After that, nothing subtraction, and here subtracted by 1. That's it. And since there is power, this will be pi by 2. So answer will be pi. So here the answer is coming out to be pi. The value of I is coming out to be pi. So here 4 into value of I is coming out to be pi. So this will be the answer. 4 pi will be the answer. But sir, this much long process will I do in the examination hall? In the examination also till this point it was fine. Then I do the substitution and I get the answer to be pi. So this much long process will I do in the examination hall? No. X square plus y square. Whenever you see x square plus y square, polar coordinate system, method 3. Method 3. Whenever I see x square plus y square, I can move to polar coordinate system. I will make the diagram again. I know what area I am supposed to find out. Simply I will show that area and I will move to polar coordinate system. So in the polar coordinate system, which two variables we are having? What is our answer? Sir, I know the answer is for the region, the area is for the region I am supposed to calculate dx dot dy. In the xy plane, I am supposed to calculate dx dot dy for the given region. This is the given region R. This is the given region R. In this region R, I am supposed to calculate double integration dx dot dy. But I can replace dx dot dy by something else, right? When I am moving on this disk, I am moving in the direction of R as well, and along with that I am moving in the direction of theta as well, right? When you move in the direction of theta, how much do you move? R d theta. And when you move in the direction of R, how much do you move? dr. So I told you dx dot dy can always be replaced with r dr d theta. Also we used to write down sometimes as in cylindrical coordinate system we used to write down rho d rho d phi. So there this theta used to be phi. In a cylindrical coordinate system we used to show it by phi in cylindrical coordinate system, and we used to show the radius by rho. So it is just the notation, nothing else. I hope you are not getting confused. So r dr d theta, this is how I can replace. So dx dy could be replaced with r dr d theta. R dr d theta. What was the radius? Here the equation was x square plus y square equals to 4, right? This was the equation, x square plus y square equals to 4. This was the equation, or less than 4. So what is the radius? Radius is going from 0 to 2. Radius is going from 0 to 2. And what about theta? Theta is going from 0 to complete circle I need to take. Theta is going from 0 to 2 pi. Theta is going from 0 to 2 pi. So what will be the answer? R square by 2. Radius is going from 0 to 2. First I will solve the limit of R, right? This much integration I will be solving. So theta going from 0 to 2 pi. This will remain as it is. R dr would be r square by 2 with the limit going from 0 to 2 dot d theta. So 4 by 2 will be 2. Theta going from 0 to 2, 0 to 2 pi dot d theta. Integration of d theta will be theta only, 0 to 2 pi. Answer is 4 pi unit square. 4 pi unit square. This is the answer. 4 pi unit square will be the answer. Understandable? Okay. So when you move on this disk, you are moving in the direction of r as well, and you are moving on the direction of theta as well. So when I move in the direction of r, how much do I move? Dr. In the direction of theta, how much do I move? R d theta. So dx dy could be replaced with r dr d theta. So r dr d theta I replaced, r going from 0 to 2, theta going from 0 to 2 pi. Sir, how this is coming? This we have already understood in that 2D coordinate system. We have studied 2D coordinate system. What was 2D coordinate system? Rectangular and polar. Then we studied 3D coordinate system. In 3D coordinate system, we studied Cartesian, cylindrical, spherical. So everything should be there in your mind. Okay. Based on that, we will solve the problem. Very easily we got the answer here. So from now onwards, whenever I would see x square plus y square, whenever I would see x square plus y square, I will be solving it using polar coordinate system. Understandable? All good? All fine? Let's move to the next question. Determine the curved surface area of the portion of the cylinder x square plus y square equals to 4 lying between the planes z equals to 0 to z equals to 1. So now we are moving from 2D to 3D. Now we are moving from 2D to 3D. From 2D to 3D we are moving. This is your x, this is your y, and this is your z. X square plus y square equals to 4. What will be the equation of the circle? X square plus y square equals to 4. This is the circle, no? X square plus y square equals to 4. This is the circle. So let's make a complete structure in this manner. Right, so this is minus z, this is minus y, and this is minus x. So this is the circle x square plus y square equals to 4. X square plus y square equals to 4. What will be this point? So this point will be y coordinate I am taking, no? So x equals to 0, y equals to 2, because radius will be 2, no? So y equals to 2 and x equals to 0. What will be this point? X equals to 2, y equals to 0, z equals to 0. What will be this point? X equals to 0, y equals to minus 2 and 0. What will be this point? X equals to minus 2, 0, 0. And this circle has been made on which plane? What is this plane? This xy plane. What is this xy plane? This xy plane is known as z equals to 0 plane. So this circle has been made on z equals to 0 plane. So this plane is z equals to 0 plane, or you can call it xy plane. They are talking about the cylinder. That means you need to make x square plus y square equals to 4 kind of these kind of circles again and again you need to make. These circles you need to make again and again. You need to make again and again until you reach z equals to 1. Until you reach z equals to 1. So that means when you have reached z equals to 1, till that point you need to keep on making the circles. Z equals to 1. Till this point you need to keep on making the circles. So this is the cylinder you will be able to make. Here your z is equals to 1. Z equals to 1. Here your z is equals to 1. Z equals to 1. And what will be the radius here? What is the radius? This radius is nothing but, this radius is nothing but, this radius is nothing but 2. This radius is nothing but 2. This radius is nothing but 2. Okay. This radius is nothing but 2. What is the height? Height is from z equals to 0 to z equals to 1 you are going. That means the height here is 1. The height here is 1. This height is 1. Well, let's show it this side. This side I am showing. The height is 1. Curved surface area I need to find. Basically, this is the cylinder. This is the cylinder is there. So this curved surface area I need to find. Do you remember the curved surface area? By simple class 11, 12 we are solving. Not class 11, 12, class 9th. In class 9th we used to find out curved surface area. So we used to write down curved surface area. That used to be, for the cylinder it used to be 2 pi RH. So 2 pi into r. What is the radius? Radius is 2. And what is the height? Height is 1. So what will be the answer? 4 pi unit square will be the answer. But do I need to solve in this manner? Absolutely not. I need to solve by calculus. So how will I solve by calculus? Curved surface area I need to find. So this will be the curved surface area, no? This will be the curve. This will be the curvature. Are you able to understand this point? This will be the curvature. Let's remove this point now. This point is not a big matter of concern. Let's remove this point. Okay. So curved surface area I need to find. This is the curve, no? This is the curve. This is the curve. Curved surface area I need to find. Now just let me know on this curve, on this particular curve, who all are varying. Go to cylindrical coordinate system. Go to cylindrical coordinate system. Just think about cylindrical coordinate system. Cylindrical coordinate system. Cylindrical coordinate system. Just think about cylindrical coordinate system and let me know on this curve which all coordinates are varying. On this curve, is my rho constant? Rho. This radius I am showing, which is 2, that is actually rho, no? Is my rho constant on this curve? Rho equals to 2, that is constant. On this curve, on curvature, on curved surface area, your rho is constant. Say yes or no. Your rho equals to 2, which is constant. Here z is varying, right? Z is varying. On this curve, here z was 0, z became 1. So on this curve, if you see on this curve, z equals to 0 to z equals to 1, we are going. So z is varying. Z is varying. dz, z is varying. That means z is going from 0 to 1. Along with that, who is varying? Phi is also varying, no? What is phi? Phi is the angle. What is phi? If you remember, I hope you are not forgetting. What is phi? Phi is the angle made with the x-axis in the anti-clockwise direction. This was your phi. So phi is also varying, no? On this curved surface, phi is going from 0 to 2 pi. So phi is also varying. And in the direction of phi, how much do you work? In the direction of phi, sir, we work for rho d phi. Say yes or no. With phi varying from 0 to 2 pi. With phi varying from 0 to 2 pi. Is that understandable to you? So on this curved surface, who is varying? Phi is varying and z is varying. On this curved surface, just look here. Phi is varying in this direction and z is varying in the upper direction. Are you able to understand this point? So if I make a curved surface like this, so phi is varying in this manner. This is phi. So how much we are moving here? Rho d phi. And z is moving in the upper direction, that is dz. Phi is moving, rho d phi, z is moving in the upper direction, dz. Is that clear to you or not? This is rho d phi. So rho d phi and dz. Rho d phi and dz. This much we are moving. So what is this small surface area? This small surface area is nothing but rho d phi dz. Sir, in the examination, how I will be able to think this much? With the practice, you will be able to think. Other thing is that on this curved surface, who is constant? Rho is constant, no? So you know one thing. What do you know? In the direction of rho, how much do I work? D rho. In the direction of phi, how much do I work? Rho d phi. In the direction of z, how much do I work? dz. On the curved surface, who is constant? Rho is constant. Rho is constant. On the curved surface, rho is constant. What I need to care about? I need to care about the surface area. So if rho is constant, apart from rho, which two coordinates are left? These two are left. So this will be my surface area. So here your thought process is 0. You don't need to think. This is a technique. That, sir, three coordinates are there, rho, phi and z. In the direction of rho, I work d rho. In the direction of phi, I work rho d phi. In the direction of z, I work rho dz. Sir, on my curved surface, rho is constant. So apart from rho, whatever two coordinates we are getting, that will be my small surface area. Or you can think in this manner, sir, this is my curved surface. So on the direction of rho, I work rho d phi. On the direction of z, I work dz. So rho d phi dz, that will be the small surface I will be having. So rho d phi dz, that will be the small surface I will be having. Okay. So what I am supposed to find out? I am supposed to find out the area. So on this curved surface, rho d phi dz. How the phi is going? Sir, phi is going from 0 to 2 pi, right? Phi will go from complete circle, it will make, no, 0 to 2 pi. And z will go from 0 to 1. Z will go from 0 to 1. And what is the value of rho? Here, sir, value of rho is fixed, which is equals to 2. Right? Value of rho is fixed, which is equals to 2. Don't do this kind of error in the examination. Rho equals to 4. A lot of student I have seen, x square plus y square equals to 4, rho equals to 4. Everything will be messed up. Okay? Don't do this error. Rho equals to 2 is fixed. So 2 I can take outside. Both of the limits are constant this time. Z going from 0 to 1 and phi going from 0 to 2 pi. Okay, d phi dz. So if I solve this one, what I will get? D phi integration here, z going from 0 to 1. So integration of d phi will be nothing but phi only, phi going from 0 to 2 pi dot dz. So integration z going from 0 to 1, this will give you 2 pi dot dz, and 2 is already going outside, 2 is already going outside. So 2 into 2 pi will go 4 pi, z going from 0 to 1 dz, 0 to 1 dz. So integration of dz would be nothing but z only, z going from 0 to 1, z going from 0 to 1. So what will be the answer? 4 pi will be the answer. This will be the answer. 4 pi will be the answer. So what is the answer? 4 pi unit square. Here also the answer is 4 pi unit square. So whenever I see x square plus y square, but it is going in the 3D. So what I thought of? I thought of a 3D coordinate system. That means I thought of a cylindrical coordinate system. Along with that, it was making a cylinder only. So that's why I thought of cylindrical coordinate system. In the examination, very easily I would be able to think x square plus y square equals to 4, z going from 0 to 1. So curved surface I need to take. Curved surface are rho d phi dz, z going from 0 to 1. That's it. This would be the answer. Very good question. In a very good way, we have wrote down the answer. Understandable? Well and good. Now, next topic, very important. You need to find out the curved surface area again, but this time z will be a function of x comma y. Here z was a function of x comma y. No, z was constant going from 0 to 1. X square plus y square equals to 4. Z was constant 0 to 1. But if z is a function of x comma y, then what will be your curved surface area? So, sir, that curved surface area would be nothing but a double integration under root 1 plus zx square plus zy square dx dy over the region R. Where what is this region R? This region R is the region in xy plane. Sir, how this formula came, that I am not going to tell. But how to use this formula, that I am going to tell. And what is zx? Zx is del z by del x. And what is zy? Zy is nothing but del z by del y. So you will be able to remember it as well, because we are going to solve a lot of problems, and along with that you will be able to solve the problems as well. Otherwise it would become very difficult. And I will be explaining you the meaning of this formula as well. What we need to find out? We need to find out the curved surface area only, but this time z is given as a function of x comma y. Here z is given as x plus y. So z is given as a function of x comma y. So what this question is saying, that you need to find out the surface area of the portion of the plane z equals to x plus y lying above the rectangle, x going from 0 to 2, y going from 0 to 3. So what this question is saying, that there is a 3D coordinate system where x is going from 0 to 2 and y is going from 0 to 3. X is going from 0 to 2 and y is going from 0 to 3. This is your x, this is your y, and this is your z. So x is going from 0 to 2 and y is going from 0 to 3. So here what will be the coordinate? X is 2, 0, 0, 0, 3, 0. So this is the scenario. This is the scenario. This is the scenario. Okay. So this is the scenario. In this much portion, there will be a function of z, which is x plus y. I don't know how the structure would be there. I don't know what will be the structure. I am not sure about the structure here. In this much portion, there will be some structure. In this much portion, there will be some structure. I don't know what will be that structure. I don't know what will be that structure. That would be some structure that I am not sure how that structure would look like. The equation of that structure is also given, but I don't care about that. Some structure would be there. Some structure would be there, which is given as z equals to x plus y. So because of this structure, there will be a curved surface area, no? You will get some curved surface area. Let's just say this structure is nothing but cylinder only. The structure is nothing but cylinder only. Although it will not be a cylinder, but let's assume this is a cylinder only. So how much curved surface area is there? This is what you are supposed to find out. So first of all, what I would see, that z is a function of x comma y. So if z is a function of x comma y, no, the very first thing that I will find out, the z is given as x plus y. So very first thing I will find out, that is zx. That means del z by del x. What that is coming out to be? that is coming out to be 1. After that I will find out zy, that means del z by del y, what that is coming out to be, that is also coming out to be 1. And after that I will find out this factor, which is under root 1 plus zx square plus zy square, that is coming out to be nothing but 1 plus 1 plus 1, that is under root 3. So my curved surface area would be nothing but double integration region R under root 3, whatever this factor that I find out, dx dy. Now in the xy plane, what is the region that you are making? In the xy plane, sir, I am making a rectangle. In the xy plane, what region we are making? In the xy plane, what we are making? In the xy plane, sir, we are simply making a rectangle. In the xy plane, we are simply making a rectangle. This is your x, this is your y. So this point is 0, 3. This point is 2, 0. This point is 2, 3. So in xy plane, we are simply making a rectangle. So under root 3, this is the region. Now we need to calculate dx dot dy in this region R. What we need to calculate? Dx dot dy in this region R. What does this represent? What does this represent? This simply represents the surface area. This simply represents the surface area of R. And what is the surface area of R? What is this length? This length is 2. This length is 2. And what is this length? This length is 3. So what is the surface area? 2 into 3, that is 6. So under root 3, 2 into 3, that is 6. So 6 under root 3. This will be the answer. This will be the answer. So this is how we need to solve the problem. Did you understand the concept here? The concept is that z is a function of x comma y. How the structure would look like, that I don't know. I don't care how the structure would look like. I only need to find out the curved surface area. So for finding out the curved surface area, what I would do, I would find out zx, I would find out zy, and I would find out this factor, which is under root 1 plus zx square plus zy square. I will get under root 3 outside. Now I am simply supposed to find out this particular integration, which is simply the curved surface area of this much structure. Sorry, which is simply the surface area in a xy plane. In xy plane, what is the surface area? That is 3 into 2, 6. 6 under root 3 is the answer. So curved surface area of this particular structure would be 6 under root 3. It would be 6 under root 3. That would be the answer. Is that clear to you? We will solve more problems. It will become more clear to you, and it is important for your GATE examination this year. What I feel is that question might be coming from here, because these questions they have already asked. But now this is something that I feel will be important for you. Okay, let's go to this one. First of all, we will solve this problem, and then we will talk about how this will look like and what is the meaning of first octant. First, let's talk about what is the meaning of first octant. What is the meaning of first quadrant, second quadrant, third quadrant? So when there are only two x's, no, x and y, x and y. This is x, this is y. So this is your first quadrant. First quadrant. This is second quadrant, this is third, and this is fourth. Right? When there are three axes, no, so you will end up making 8. You will end up making 8 octant. Okay? If you look closely, if you are able to visualize, then very easily you can think that we are making 8 octant. Which 8? 1 here, 2 here, then 3, 4 downward, then 5, then 6, and then 7, 8 downward. Which downward I am talking about? These downward I am talking about. 7 and 8. So 8 octant we will be able to make. Are you able to understand this point? And this is known as first octant. First octant means always they will talk about first octant only. First octant means all x, y, and z all are positive. X, y, and z all are positive. This is known as first octant. All x, y, z all are positive. This is your x, this is your y, this is your z. All are positive. So this is known as first octant. Okay. This is your first octant. So in the first octant, in the first octant, what will be the surface area of this plane? So how this plane would look like, that I don't know, and I don't need to care about it as well. I only know about first octant. That means x is going from 0 to infinity, y is going from 0 to infinity, and z is going from 0 to infinity. This is what I know. Okay. So how this structure look like, that I don't know as of now, but I will learn how this structure would look like. So as of now, what I need to care about, that sir, z is given as a function of x comma y. Yes, it is given as a function of x comma y. Yes, it is given as a function of x comma y. So can I find out zx? Yes sir. Zx means differentiation with respect to x, partial differentiation with respect to x. Can I find out zy? Yes, that would be -3. So what will be the factor? 1 plus zx square plus zy square. That factor would be under root 1 plus 4 plus 9, right? So that would be under root 14. Under root 14. So this factor we have find out. Now what will be the surface area? What will be the surface area? Sir, the surface area would be nothing but whatever the factor that you have find out, under root 14 dot dx dy in the region R, right? Now from where to where the limit of x and y would go, that I don't even know. From where to where the limit of x and y would go, that I don't know. Basically the scenario is that what I would have done, now I need to put the limit of x and y. No, here what I would have done, I would have taken the projection. I would have put a sunlight here. Now I need to put the limit of x and y. So z is not my matter of concern. My matter of concern is that how my structure would look like if I squeeze this structure on xy plane, how it would look like on xy plane. That is my target. No, so z is gone. So similarly, what is given here? The equation is given as 2x plus 3y plus z equals to 6. 2x plus 3y plus z equals to 6. This is what is given. Now my z is gone. Now how the structure would be looking like? In 3D, I don't know how the structure would be looking like. I just know one thing, that x, y, z will be varying some values, and based on that there will be some 3D structure that I don't know. How the structure would look like, that I don't know. There will be some 3D structure. But there would be some projection of this structure on xy plane, right? On xy plane there will be some projection. On xy plane there will be some projection of this structure. Some projection would be there. What that projection would be? Sir, what you need to do is that you just need to remove this z. That means put z equals to 0. Put z equals to 0, what you are getting? 2x plus 3y equals to 6. There you go. In xy plane, this will be your structure. That's it. Make xy plane and this will be your structure. And only positive xy plane I need to make. Why is that so? Because my x is going from 0 to infinity and y is going from 0 to infinity. So in xy plane, this will be the structure I will be getting, which is 2x plus 3y equals to 6. That means how the graph would look like? The graph would look, you can draw the graph in any manner. This is a linear equation. The graph would look somewhat like this. At if you put y equals to 2, so x has to be 0. And if you put x equals to 3, y has to be 0. There you go. This is what you will get. So this is the projection that you will be getting. When you put the sunlight here, and you squeeze this structure downward, then this is the projection you will be getting. Is that clear to you? So what we are supposed to find out? Under root 14 you take outside. We are supposed to find out r dx dy. What this would represent? This would simply represent the surface area. Surface area of r. What is r? This is r. In the xy plane, what is my r? This is my r. So this would simply represent the surface area of this. Surface area of region R. So what will be the surface area? Sir, this width is 3, this height is 2. So sir, surface area would be nothing but under root 14. This is a triangle, so half into base into height. So answer would be 3 into under root 14. That would be the answer. This is the answer. That's it. So 3 into under root 14 would be the answer. 3 into under root 14 would be the answer. Is that clear? Now let's draw this one. Like what all we know how to draw. What all 3D structure we know how to draw. Which all 3D structure you are comfortable with. Sir, I am comfortable with z equals to x square plus y square. Do you know how to draw it? Yes sir, it is a elliptical paraboloid. Elliptical paraboloid. This I am already comfortable. I already know how to draw it. Do you know what is z square equals to x square plus y square? Yes sir, it is a cone. It is a cone. So I am already comfortable with this. Do you know what is x square plus y square plus z square equals to some constant, let's just say a square? Yes sir, this will be a sphere. That also I am already comfortable. Now I will be comfortable with x by a plus y by b plus z by c equals to 1 in first octant. In first octant. In first octant. Only in first octant I am going to draw. Okay, so what is our equation given? 2x plus 3y plus z equals to 6. So our equation is given is 2x plus 3y plus z equals to 6. So what you do, you take this 6 downward. That means you divide 6 on left side and right side. So what you will be getting? X by 3 plus y by 2 plus z by 6 equals to 1. What you would do? You would make x, y, z plane. You would make x, y, z plane. So this is our x, this is our y, this is our z. When you put x equals to 3, then y and z has to be equals to 0. When I put x equals to 3, y and z has to be equals to 0 because 3 by 3 will be 1. So at x equals to, so on x axis, the point will be 3, 0, 0. On y axis, the point will be at x equals to 0, y equals to 2, z equals to 0. And on z axis, the point will be x equals to 0, y equals to 0, and z equals to 6. So these are the points. On z axis, this will be the point. On y axis, this will be the point. On x axis, this will be the point. Simply join these points. Simply join these points. Simply join these points. Simply join these points. So this kind of structure you will be getting. So this is the plane that you will be getting. This is the equation of this plane. This plane, can you see? Can you see this plane? Can you see this plane? This plane. Can you see this plane? The equation of this plane is, this is the plane that is there. The equation of this plane is 2x plus 3y plus z equals to 0. This is the plane that we are having. So this was the structure. What we were supposed to find out? We were supposed to find out the surface area of this one. This surface area, whatever the dotted that I have made, no, whatever the dots that I have made. So we were supposed to find out the surface area of this one. What surface area came out to be? The surface area came out to be 314. So this area was nothing but 314. This area was nothing but 314 unit square. If these kind of questions are coming in the examination hall, no, then out of 1,000 people, 2 people will be able to solve these problems. Out of 1,000, only 2. So this surface area, if they are asking, the volume, then everyone studies the volume, but no one studies the curved surface area, and which I feel this year it might be coming in your examination hall. If not this year, the next year. Soon it is coming. Secondly, sir, how to take the projection now? Although if I don't know how to draw the graph, then also I can take the projection. Simply put z equals to 0. That means I need to come on xy plane. What is the meaning of xy plane? Xy plane simply means z equals to 0, no? So on xy plane, how it would look like? This is how it would look like. From this structure as well, you can think on xy plane how it would look like. If I just squeeze it downward, then what I will be getting? If I squeeze it downward, then this is what I will be getting. No, if I squeeze it downward, then this is what I will be getting. Just squeeze this structure downward on xy plane, then this is the structure that I will be getting. And this is the structure I will be getting. Isn't it? A triangle, a triangular shape. On x axis 3, 0, 0. On x axis 3, 0. On y axis 0, 2. On y axis 0, 2. And z is 0 only, So isn't it the same triangular structure we are getting? Yes, we are getting the same triangular structure. Although even if we don't know how to draw this particular plane, then also it is fine. But if we don't know how to draw this, plane, then also we will be able to solve. If we know how to draw this plane, then also we will be able to solve very easily. So in this plane, we will be very easily able to solve. What I would do is that I would simply calculate this under root 14 factor, then dx dot dy. That means they are simply talking about this surface area. So what will be this surface area? Half into base, which is 2, height is 3. So the surface area is 3. Answer will be 3 into under root 14. So this will be the complete surface area that you will be getting. Sir, how this formula came? Sir, you are using this formula. How this formula came? It will be very difficult to understand. Okay, it will be like only calculus if you need to study in your life. No, then I would be giving the derivation of this formula. As of now, we can ignore it. Okay, can you please simply ignore it for me? As of now, can you simply remember it? Under root 1 plus zx square plus zx square dot dx dy. Okay, only simply this you need to remember. We will solve more problems. Eventually, you will be able to keep it in your mind. Till this date, there is no PYQ on this, but who knows, it might be coming. So I have taken 1 question, 2 question, 4 question I have taken, 5 question I have taken, 3, 4 and 5 questions I have taken. Okay. So after these 5 questions, you will be completely comfortable whichever the question they ask. and standard diagram they will give. This is an elliptical paraboloid, right? Between the planes z equals to 0 to z equals to 1. What you need to find out? Curved surface area you need to find out. So simply find it out. Can you draw the structure? Let's just say I don't know how to draw the structure. How will I solve the problem? If I don't know how to draw this structure, how will I solve this problem? So what I would do? What I would do is that, first of all, z is given as x square plus y square. Z is given as x square plus y square. What I need to find out? I need to find out zx, that is 2x. I need to find out zy, that is 2y, right? Then this factor 1 plus zx square plus zy square. What will be this factor? 1 plus zx square is 4x square plus 4y square. So the factor is 1 plus 4 x square plus y square. So now my surface area would be nothing but under root 1 plus 4 x square plus y square dx dy, region R. Now what will be the region R? Can I simply put z equals to 0? So the region R would be x square plus y square equals to 0. This is nothing. This is simply a point. Look, z is going from 0 to 1, no? Z is going from 0 to 1. I don't know whatever the structure is there, but z is going from 0 to 1. That means I will get these kind of circles. X square plus y square equals to 0, x square plus y square equals to 0.5, x square plus y square equals to 0. X square plus y square equals to 1. So these kind of structure these kind of circles I will be getting. So x square plus y square equals to 0, x square plus y square equals to 0.5, x square plus y square equals to 1. These kind of circles I will be getting. So this is my z, this is my x, this is my y. And when I squeeze it on the xy plane, when I squeeze it from here, if I squeeze it, then what I will get? On xy plane, what I will get? I will get a circle of x square plus y square equals to 1. Like blindly you cannot put z equals to 0. If I want to remove that z axis, then blindly I will put z equals to 0. That is wrong. No, I need to squeeze it downward. So z is going from planes is z equals to 0. This is your z equals to 0 plane, and this will be your z equals to 1 plane. So plane is going from z equals to 0 to z equals to 1. So what I will be getting? I will be getting what kind of structures? I will be getting circle, circle, circle. So if I squeeze it downward on xy plane, I will get a circle of x square plus y square equals to 1. What I will get? I will get a circle of x square plus y square equals to 1. X square plus y square equals to 1. This is what I will be getting. This is what I will be getting. X square plus y square equals to 1. This is my x axis. This is my y axis. So I will be getting x square plus y square equals to 1. And what is the region R? This is the region R. This is the bounded region R. This is the bounded region R. This is the bounded region R. So what we are supposed to find out? We are supposed to find out area equals to bounded region R under root 1 plus 4 x square plus y square dot dx dy. And what is this region R? Can I take this outward now? It is not constant. I cannot take it out. Previously, we were getting under root 14 constant outward. Here also we got under root 3 constant outward. So this was simply representing the surface area. Now is it representing the surface area? Is it representing the surface area? Is it surface area? Is it surface area? Surface area of circle. Is it surface area of circle? No, absolutely not. What is the surface area of circle? Surface area of circle is dx dot dy. But here some other factor is also coming. No, you need to treat this factor as well. So what I will do? 1 plus 4 x square plus y square dot dx dy. Strip we need to take. In this region, if we need to cover this complete region, what we need to do? We need to take the strip. No other way. We need to take the strip. So this vertical strip I am taking. When I take this vertical strip, from where to where my y is going? Y is going from under root 1 minus x square. From here you can see, no, x square plus y square equals to 1. So y square would come 1 minus x square. So y would come plus minus under root 1 minus x square. So y is going from minus under root 1 minus x square to, this is your y. plus under root 1 plus 1 minus x square. And what about z? Sorry, what about x? And if you have taken the limit of y, then what will be this coordinate? This coordinate would be x equals to 1, y equals to 0, x equals to minus 1, y equals to 0. So x is going from minus 1 to 1. So x is going from minus 1 to 1. Minus 1 to 1. So x is going from minus 1 to 1 and y is going from minus under root 1 minus x square to plus under root 1 minus x square. Solve this integration now. First of all, you need to solve it with respect to y, and then you need to solve it with respect to x. Is it very easy to solve now? Like, what I need to do now? What I need to do? That x is going from minus 1 to 1. Minus 1 to 1. First, I need to solve it with respect to y. That means y is going from 1 minus x square to 1 minus x square, minus 1 minus x square to plus 1 minus x square under root 1 plus 4x square. This will be treated as constant. This will be treated as constant plus y square dot dy. So this much we will solve first. This much we will solve. This we will solve. Now some answer we will be getting. Answer will come out to be as a function of x, right? When I solve it, look, when I solve it, this is already a function of x. This will be treated as constant. This will be treated as constant. This will be a constant value. Constant plus y square under root dot dy. When I solve it and put the limit, I will put the limit of y, which is in terms of x. So y will become in terms of x. So this will turn out to be a function of x. So what I will get? Minus 1 to 1. This will turn out to be a function of x dot dx. Then I will have to integrate this one, and then I need to put the limit, and some numerical answer I will be getting. Some answer I will be getting. Now, is it easy to solve? Absolutely not. So can I proceed with this method? Absolutely not. I cannot proceed with this method. What does that mean? Told you one thing. Just as I see x square plus y square, I will move to cylindrical or spherical coordinate system or polar coordinate system as well, because eventually we are coming on xy plane only. So this is what we are supposed to solve. This is something that we are supposed to solve. So now my target is, what is our target? Our target is solving this particular scenario. Which particular scenario? This particular scenario, that we are supposed to solve this a, which is over the region R under root 1 plus 4 x square plus y square dx dy. This is what we are supposed to solve. And what is our region R? This is our region R, which is this. This is our region R, right? Circle is x square plus y square equals to 1. Can you replace dx dy? Absolutely, sir. This is our region R, no? This is our region R. This is our region R. So what we used to do? First we used to assume a R here with the angle R here with the angle theta in anti-clockwise direction. So we used to write down x equals to R cos theta, y equals to R sin theta, right? And then what we wrote down? Dx dy, which is a surface area, and here what will be the small surface area? In the direction of R if I move, that would be dr, and in the direction of theta if I move, that would be r d theta. So dx dy could be written as r dr d theta, and I can replace x as r cos theta, y as r sin theta. So what will be x square plus y square? What will be x square plus y square? Here x square plus y square will be r square cos square theta plus r square sin square theta. That would become r square. So what integration you are getting? Under root 1 plus 4r square. This dx dy would become r dr d theta, with r going from 0 to 1 and theta going from 0 to 2 pi. This integration we are supposed to solve now, which is much easier than this one. Much easier than this one. So what I would do? I would assume 1 plus 4r as t. So basically first I am supposed to solve this one, no? First I am supposed to solve this much. Then I will put the limit of theta, which is constant. Although this is also a constant limit, basically I can break down in this manner, no? Because both are constant limit now. Both are constant limit. So this will also give you a constant answer. 1 plus 4r square dot r dr multiply with, this will give you one constant answer. So here some constant value will come. then that constant value can be taken outside, theta going from 0 to 2 pi dot d theta. Now you know that answer of this one will be 2 pi only, because d theta will give you theta, and put the limit 2 pi minus 0 will be 2 pi. So 2 pi into r going from 0 to 1 under root 1 plus 4r square r dr. What is this? This is your I. So we are supposed to find out I. Okay. So can you find out this I on your own? 1 plus 4r square you will assume as t, and your job would be done. So what we are supposed to find out? We are supposed to find out I. Why I will have to add a page. So my I is r going from 0 to 1 under root 1 plus 4r square dot r dr. So 1 plus 4r square equals to t, I will assume. Or shall I assume t square? It would be easier, I guess. If I assume t square, it would be easier. 8r dr dot 2t dt. Right? So r dr would become t dt by 4. And this will be t square only. Yes. So what will be the value here? If r is 0, then 1 plus 4 into 0 square would be equals to t square. Value of t square equals to 1. So t will be plus minus 1. So what I will take? I will take the positive value. R is going from 0 to 1. So here also I will take the positive value. T will be equals to 1. And if r is 1, then 1 plus, if r is 1, then t will be under root 5. Right? So t is going from 1 to under root 5. Now 1 plus 4r square is t square. So under root t square, someone would say it should be mod of t, but we are taking the positive values only. So t. R dr could be replaced as t dt by 4. Right? So what is the answer? 1 by 4 outside, 1 to 5, 1 to under root 5, t square dot dt. So that is coming out to be 1 by 4, t cube by 3, 1 to under root 5. That is coming out to be 1 by 12, 5 under root 5 minus 1. This is the value of I we are getting. So this is the value of I we are getting. So what is the area? Area is 2 pi into I. 2 pi into I is 1 by 12, 5 under root 5 minus 1. So area is pi by 6 into 5 under root 5 minus 1. This is the area. If these kind of questions come in the examination hall, they will be treated as one of the finest question of a GATE examination. Not only mathematics, but one of the finest question of GATE examination. Okay. So this will be the answer. Did you understand? A lot of points we have understood here. First of all, this factor was not constant. Directly we cannot take it outside. So we are directly not getting the surface area. If we are not directly getting the surface area, then we just need to solve this particular integration. How we will solve this particular integration now? Just simply over the region. What is this region? I need to cover this region. If I need to cover this region, then y should go from 1 minus under root 1 minus x square to plus under root 1 minus x square. So this is how your y should go, and how your x should go. X should go from minus 1 to 1. X should go from minus 1 to 1. Then I go to know that, sir, this integration is very difficult. In the examination, I will not even come to this step. Just as I get to know that, sir, 1 plus 4x square plus y square circle is being made, I will understand one thing. What I will understand? I will understand that it has to be solved by the polar coordinate system. So this is how I will solve using the polar coordinate system. Is that clear to you? Okay. So this is how I will be solving it. But what will be the diagram? If I want to make the diagram, can you make the diagram of this? What they are saying? You need to make the paraboloid z equals to x square plus y square. So paraboloid you need to make. So paraboloid will be extended till infinity, no? Z equals to x square plus y square. If I am asking you to draw z equals to x square plus y square, will you be able to draw it? Just let's make some space. Okay, just 1 second. I am making some space here. Then I will draw this structure, and I will tell you that what this question is trying to say. That if I make a paraboloid, first of all, I know that z cannot be negative because x square plus y square it is. So z cannot be negative. So if I make a paraboloid, this paraboloid will be extended till infinity. I know that, sir, this will end up making a paraboloid only, which will be extended till infinity. It will keep on going. Till infinity, it will keep on going. This paraboloid will keep on going. In between, I can make some circles. This will keep on extending till infinity, and it will keep on extending till infinity. But what they are saying, you need to consider the paraboloid between two planes, which is z equals to 0. Z equals to 0 plane will be xy plane only. Z equals to 0 will be this plane. And z equals to 1 plane. What will be z equals to 1 plane? This will be your z equals to 1 plane. Let's just say here it is z equals to 1. So what will be your z equals to 1 plane? This will be your z equals to 1 plane. This will be your z equals to 1 plane. Z equals to 1 plane will be this much. This will be your z equals to 1 plane. This will be your z equals to 1 plane. Z equals to 1 plane. Here z is equals to 1. So this is your z equals to 1 plane, which is extended completely, which is extended like this, which is extended like this. Okay. So between z equals to 0 to, this was your z equals to 0 plane, this was z equals to 0 plane, z equals to 0 plane also I am making, which is xy plane only. This is your z equals to 0 plane. Z equals to 0 plane, and this is z equals to 1 plane. So between z equals to 0 to z equals to 1 plane, what kind of structure you are getting? Sir, this kind of structure we are getting. This much structure we are getting. This much structure we are getting. Arey bhai. This much structure we are getting. This much structure we are getting. So this much bowl kind of structure we are getting. This much bowl kind of structure we are getting. So here in this much region, in this bowl kind of structure, what is the curved surface area that we are supposed to find out? Whatever the curved surface area is there, that we are supposed to find out. So it will be extending till infinity, but between 0 to 4 only we are supposed to find out. This is what they are saying. This is what they are saying. If I show it more on 3D, I have one diagram. Yeah, this will be the diagram, no? So here, this is the some next question where I am asking between 1 to 4, but here what they are asking between 0 to 1. That means this curved surface area they are asking. For this question, this curved surface area they are asking. This curved surface area. But only in 2D we are able to see, but backward as well there will be some surface area, no? So this curved backward surface area also they are asking. This surface area they are asking between 0 to 1. In some question I am asking between 1 to 4. Okay. So this question we will solve, but later on. But yeah, this question is done. Let's try solving this problem. Solve it on your own. Find the surface area. Find the surface area of the portion of surface z square equals to x square plus y square enclosed by the cylinder x square plus y square equals to 1. One blunder you are going to do here. Okay, people will be able to solve this question, but they will do one blunder. Okay, what blunder they will do, they will find out. So solve this question. If you remember the structure of this cone, this will be a cone, right? You remember z square equals to x square plus y square, this will be a cone. But what kind of cone it would be there? Can z take negative value? Z can take a negative value as well. If z can take negative value, then whatever the surface area you are going to find out, so from where to where you will take the limit? You will take the limit from z going from -1 to 1, or z going from 0 to 1, or z going from where to where? That you will have to think. Spend your time, draw the diagram, think about it and solve this problem. Okay. So let me take a break and then I will come back. Yeah, so did you solve this question? So what kind of surface it would be? This we have already seen in the basics, sir. This surface would be nothing but a cone. But here there is an interesting part that z could be negative as well, because sir z square is given. Z square is given. Z can take value 1 minus 1. X square plus y square has to be positive. That I know. X square plus y square, this particular value will come out to be positive. But let's just say z square is coming out to be x square plus y square, which is 2. So what is the value of z? Z value could be plus minus under root 2. So z could be negative as well. So if you are making the cone, this cone will extend till infinity. This cone will be, sir, extending till infinity. That I know. This cone will be extending till infinity. There is no doubt in that. Extending till infinity. But it will extend till minus infinity as well. It will be there downward as well. So this is the point a lot of student would miss. So their answer would come half of the actual answer. Let's just say actual answer is alpha, then their answer would come out to be alpha by 2, because they would miss the negative part. Because what you are supposed to find out, you are supposed to find out the surface area, right? You are supposed to find out the surface area. So surface area of upper part would also be there, surface area of downward part would also be there. So this is how this would be extending, right? This is how this cone would be extending. But you need to find out the cone which is enclosed by cylinder x square plus y square equals to 1. That means we are supposed to find out only, let's just say this is your x square plus y square equals to, this is the cone which is extending till, we need to make the cylinder which is x square plus y square equals to 1. So x square plus y square equals to 1, x square plus y square equals to 1, which will be this circle. But sir, how you are saying it is a cylinder? They are saying that x square plus y square is a cylinder. X square plus y square plus x square plus y square equals to 1 is a cylinder. But sir, x square plus y square equals to 1 is actually a circle. So they are saying with respect to this particular surface that z square equals to x square plus y square. Okay, and you need to take the cylinder x square plus y square equals to 1. What does that mean? That means you need to extend the cylinder till z square equals to 1, or you can say z equals to plus minus 1. So this cylinder has to be extended till z equals to plus minus 1. This is what they are saying, that you need to extend the cylinder till z equals to plus minus 1. This is what they are saying. Is that clear to you? Let's make a clearer diagram. If the diagram does not look symmetric, then I am sorry, okay, because it is tough to make the symmetric diagram, no? इसे ठीक करना पड़ेगा यार. इसे यहाँ से पास करवाए तो इसे भी ठीक करना पड़ेगा. बाद एक सर्कल भी बनाना पड़ेगा. So yeah, this is the cylinder. So in between this cylinder here, the scenario is this is z equals to 1. This is your z equals to 1, and this is z equals to minus 1. Here z equals to minus 1. So in between whatever the surface area is coming, in between whatever the surface area is coming, 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 in between whatever the surface area is coming, this surface area we are supposed to find out. That means we are supposed to find out the surface area of a cone which is extending surface area of the cone. We are supposed to find out the surface area of this cone. On the upper side also there, on the downward side also there. So do you already know the surface area of a cone? Do you remember the formula? I also don't remember the formula actually. As far as I remember, it used to be pi RL, as far as I remember, pi RL. L is this is slanted height, right? So what is this? What is this radius? The radius is also 1, height is also 1. So this radius is also 1. This height is also 1. This height is also 1. So what will be the slanted height? What will be the slanted height? The slanted height will be, sir, 1 plus 1, that will be under root 2. So this slanted height will be under root 2, right? So if we write down, this slanted height would be under root 2. So what will be the surface area? I used to remember it used to be pi RL. So upper side would be pi RL, downward side would be pi RL. So surface area would be, curved surface area would be pi RL into pi RL. Sorry, pi RL plus pi RL. Upper side pi RL, downward side pi RL. So curved surface area would become 2 into pi into value of R value is 1, into L is under root 2. So answer would be 2 pi under root 2. So this is with respect to the class 9, 10th concept we have solved. Right now, what we need to solve? We need to solve with respect to calculus. So for that, what we need to do, we need to find out the factor which is under root 1 plus zx square plus zy square. So for that, let's find out the value of zx. So what will be the value of zx? So first of all, let me write down the value of z. What is z? Z is nothing but under root x square plus y square. Z is under root x square plus y square. So what will be zx? Differentiation with respect to x, keeping y as constant. So that would come out to be multiply with 2x. 2 and 2 will get cancelled out. Zx is coming out to be x upon under root x square plus y square. Similarly, what will be zy? Zy will come out to be y upon under root z square plus y square. So what will be the value of under root 1 plus zx square plus zy square? So you can calculate 1 plus zx square will be x square upon x square plus y square upon x square plus y square. Here it is x square plus x square plus y square. So x square plus y square divided by x square plus y square, that would be 2 only. So 1 plus 1 will be 2. So under root 2 we are getting. Okay, so this factor is coming out to be under root 2. So what is the curved surface area? So the curved surface area would come out to be under root 2 dx dy with the region R. So we are lucky that this under root 2 is coming out with the region R dx dot dy. So here what we need to take, we need to take the projection of this particular structure on xy plane, and then we need to take its area. But make sure one thing, what we need to do, what this represents? This represents the surface area in xy plane, right? But we need to make sure one thing, that we will be squeezing from the upper side as well and downward side as well. So whatever the surface area that we are getting in xy plane, we need to double it. So in xy plane, what we will be getting? We will be getting a circle of radius 1. In xy plane, we will be getting nothing but a circle of radius 1. But we need to double it. Why we need to double it? Because, sir, you will squeeze from the upper side as well, you will squeeze from the downward side as well. So that's why you need to double it. Okay, so this will be having a radius of 1. So here I can write down 1 comma 0. So what will be the surface area? Surface area here will be pi r square. Radius is 1, pi r square. But addition of pi r square again. Why is that so? Because squeezing from upper side, squeezing from downward side as well. So this will give you 2 pi. So what will be the answer? Area will come out to be 2. Under root 2 is already outside. Multiply with 2 pi. So answer is 2 under root 2 pi. That will be the answer that we will be getting. Okay. With respect to geometry as well, it could have been solved. With respect to calculus as well, we have solved 2 pi and root 2 is the answer that we are getting. Okay, so I hope this concept is clear to you, and I hope you understood what is the meaning of cylinder here. Cylinder between, you need to find out the surface area between z equals to 1 and z equals to minus 1. This surface area you are supposed to find out. So this was the important part. The downward as well, there will be some surface area. Understandable? Solve this question. Find the surface area. It will be a z equals to x square plus y square will be elliptically paraboloid. Between the cylinder x square plus y square equals to 1 and x square plus y square equals to 4. What does that mean? What do they want? X square plus y square. So between the cylinder, which is x square plus y square equals to 1 and x square plus y square equals to 4. What does that mean? That means they want you to find out the surface area between z going from 1 to 4. This is what they want. Basically, if I try to make the structure, which will be very difficult to make, but still I will try to make it. So what do they want? They want you to find out, this will be the elliptically paraboloid structure I am going to make. Elliptical paraboloid is not very tough to make, but what will be the tougher part? This will keep on extending till infinity. Right? This will keep on extending till infinity. Now the tougher part would be to make the cylinder. So cylinder of radius 4 I am going to make, and cylinder of radius 1 I am going to make. So this is the cylinder of radius 4 and this is the cylinder of radius 1. So cylinder of radius 4 will be looking somewhat like this. X square plus y square equals to 4. Right, and cylinder of radius 1 will be looking like this. right? So this is the cylinder of radius 1. Radius is 1 here. This radius is 1 and here the radius is 4. So which surface area you are supposed to find out? This curved surface area you are supposed to find out. This curved surface area you are supposed to find out. This curved surface area we are supposed to find out. Okay. So this is our target between z equals to 4 and z equals to 1. This is what we are supposed to find out. So what we need to do, we need to find out the value of zx and zy, and we need to do the process. So let's find out the zx value. Zx value is 2x. We need to find out the zy value, that is 2y. What will be under root 1 plus zx square plus zy square? This we have already find out actually, right, in one of the previous problem. So that will come out to be 1 plus 4x square plus y square. So our surface area will come out to be under root 1 plus 4 x square plus y square dx dy. Is it very straightforward? Absolutely not. Why is that so? Why it is not very straightforward? Because sir, this is not a constant, you cannot take it outside. So you need to find out dx dot dy multiply with some function. Right? Now what is this region? What is the region here? What is the region R? Can you find out the region R? Can you visualize the region R? I need to squeeze this surface. I need to squeeze this surface on xy plane. I need to squeeze this surface on xy plane. When you squeeze this surface on xy plane, what you will be getting? You will be getting two circles, one of radius 1 and other one of radius 4. If you squeeze this surface, just see this structure. If I squeeze this downward, so this circle I will be getting and another circle I will be getting. On xy plane, what I will be getting? If you look it closely, on xy plane, I will be getting a circle of radius 1, a circle of radius 1 and a circle of radius 4 on xy plane. This is what I will be getting. I hope you are able to visualize. That's why I made that diagram. So sometimes diagram is important to make because everything cannot be done with the formula. Diagram is also important. If in the examination diagram is important, no, then they would ask you the standard diagrams like elliptical paraboloid or conic structure or sphere. So those standard diagrams only they would ask in the examination. Don't worry about it. Something random they will not ask. Or plane as well, ax plus by plus cz, like x by a plus y by this plane we have seen, no, x by a plus y by b plus z by c equals to 1. So this plane is also very famous. How do we make it in first octant? Right? A 0 comma 0 comma in this kind of plane. This we have already seen. So these kind of famous structure they would ask. And if they are asking something out of the box, then they will draw the diagram on their own. Like let's just say this was out of the box, no? So they will draw this diagram in the examination only. So you will never feel that sir something out of the box they are asking, but we never studied this diagram. So this will never happen. So when you squeeze this particular surface area, so only this much area will be, this will be your region R. Are you able to understand this point? This will be your region R. Say yes or no. This will be your region R. This will be your region R. Say yes or no. So from where to where, now what I would do? I would replace dx dot dy. What I would do? I would replace x with r cos theta, y with r sin theta. So what x square plus y square will become? X square plus y square will become r square, right? And what will be dx dy? So dx dy will become r dr d theta, because in the direction of theta we work r d theta, in the direction of r we work dr. So it will become r dr d theta, right? So from where to where radius would be going? So this is the radius of 1 and this is the radius 4. So this time your r is moving from 1 to 4, not from 0 to 4, because this is the surface area, no? In this surface area, in this particular surface area, from where to where r is moving? In this region, from where to where r is moving? In this particular region. In this particular region, r is moving from 1 to 4. Here r equals to 1, here r equals to 4. R is moving from 1 to 4. R is moving from 1 to 4. And theta completely from 0 to 2 pi. Is that understandable to you? Right? So surface area A is nothing but under root 1 plus 4r square r dr d theta. R is moving from 1 to 4 and theta is moving from 0 to 2 pi. Now it is up to you, how would you solve this integration. Now I know that I need to solve this integration, and both are having the constant limit, no, both are having the constant limit. So you can solve the theta integration first as well, or you can solve the r integration first as well. If there is a variable limit, so first you will solve the variable limit, then you will solve the constant limit, but both are having the constant limit now. So this integration would be separate, and if I solve with respect to theta, I know that I will get 2 pi only. From 0 to 2 pi, d theta would give you 2 pi. So what you will be left with, a equals to 2 pi into r going from 1 to 4, r going from 1 to 4, under root 1 plus 4r square into r dot dr. This is what we are supposed to solve. Okay. So what I will do, 1 plus 4r square equals to t. 1 plus 4r square equals to t. So this will become 8r dr equals to dt. So r dr would be dt by 8. If the value of r is 1, then what will be the value of t? If value of r is 1, then value of t will be 5, and if value of r is 4, if value of r is 4, then 16 into 4 will be 64, t value of t will be 65. Understandable? If value of r is 1, then put 1 here, it will become 5. If value of r is 4, then 4 square will be 16, value of t will be 65. So what we are getting, 2 pi, t is going from 5 to 65, under root t dt by 8. What we are getting, pi by 4, t to the power 3 by 2 divided by 3 by 2, from 5 to 65. Pi by 4 into 2 by 3, 65 under root 65 minus 5 under root 5. So here what you will be getting, pi by 6, right? This will be pi by 6. Now how we are supposed to solve? 13 into 5, 13 into 5, 13 under root 3, 5 under root 5. How they have written the answer here? In which form they have written the answer? That form I need to check. 17 under root 17 minus 5 under root 5. 5 by 6, 17 under root 17. I am getting 65 under root 65. Am I doing something wrong? Pi by 4. If value of r is 4, okay. X square plus y square equals to 4. That means radius is 2, right? What is the radius? Radius is 2. Every time I say that, don't do these mistakes which I keep on doing. X square plus y square equals to 4. So radius is 2, no? This is 2 square. So radius is 2. So all these blunder I did here. If I was not having any answer, then in the examination I would have matched it up. So radius is 2 here. Radius is 2. Radius is 2. So these kind of blunder I am doing, because I just got escaped because I was having the answer. In the examination I would have matched it up, right? So radius is not 4, radius is 2. So these kind of blunder, if you also did not notice, then there is a problem, right? You should have noticed this. If you are not noticing this, then there is a problem. If r is equals to 2, then what you will get? 2 into 2, 4 into 4, 16, 17. Here you will be getting 17. Okay, so if you are not noticing it, then you are not attentive, right? But yeah, it is nearly the end of the lecture, so it might happen that you are tired. Yeah, so don't worry, it happens sometimes. I am also a bit tired now, but although I took a break, I took a bath as well, then I came back. Okay, because you would see there is a change in my t-shirt. So these kind of errors should not have happened, but actually it is 3:30 a.m. in the morning when I am recording this video. But yeah, it is what it is. This is the answer. Okay, so sorry for this blunder, that this would have been. Here also they are doing, here z equals to 4. Z equals to 4 is fine. Actually z equals to 4 is fine. Z equals to 4 is fine. Z equals to 4 is fine, but the radius will be 2 here. Okay, this radius will be 2. This radius will be 2. This radius will be 1. Z would be equals to 4 only. Z equals to 4 only, but the radius would be, here the radius is 1, here the radius would be 2. So in exam pressure as well, in a hurry, these kind of error can happen. So always take care one thing, that whenever there is x square plus y square equals to a square, so always take care radius is 2, value of z is 4, that is fine. Okay, so how to solve these kind of problems, is it clear to you? So in the examination, like, they might not give all these scenarios, right? These circles and all these things they will not give. What they would give? They would simply give this particular structure. Okay, they would simply give this particular structure and they would give you this integration. Like nothing, z equals to x square plus y square between the cylinder, all these things, nothing they will mention. What they would mention? This particular integration they would mention, and they would mention the region R is this. So only mathematics they may also ask. Here, this was the brain that we need to use. That z is going from 1 to 4, radius 1, radius 2, then we need to take the projection, zx we need to find out, zy we need to find out, and this is something we need to put, and then this will be the projection. In the examination, 95% of the time what they do is that they will give you the projection. They will give you the projection, they will give you this particular expression as well, and they will simply ask you to find out this particular integration. So what you need to do is that you need to change it into the polar form and solve this. That's it. So in the examination, least expectation they keep. But this year, IIT Madras is making the paper. So who knows, they may increase the expectation. They can ask the question from here. So we are starting from where it could be asked. But in the examination till this date, I have seen that they are asking from here. That they will give you this expression and they will ask you to integrate over this region. They will make this region as well. They will not even define in this manner. They will make this region as well. In the paper, this region will be made and you will have to integrate over this region. That's it. This much they ask. But who knows, they may ask in this manner as well. So we should be ready for everything, whatever that could be coming in the examination. Understandable? Our next topic would be about the volume. Now we will talk about volume. Surface area we have seen enough. Curved surface area also we have seen. Surface area in xy plane. How we started? We started with the surface area in xy plane. So initially everything was going in xy plane, right? XY plane. Everything was going in XY plane. So when we were done with XY plane, then what we moved with? We moved with this particular structure. That this is in 3D. So 3D, in 3D we are finding curved surface area, but here Z was constant. Z was going from 0 to 1. It was constant. Z was not a function of x comma y. After that what happened? Z became the function of x comma y. So this particular derivation I did not give you. I am sorry for that. I will not give you the derivation. But I told you the method. What we need to do, zx we need to find out, zy we need to find out, and we need to find out the vector under root 1 plus zx square plus zy square, and then dot dx dy. So based on that, we just need to take the projection and then perform this operation. Understandable? Here in the initial questions, this particular factor came out to be constant, so we only need to calculate the surface area. Here it came out to be constant. In this scenario as well, this particular factor came out to be constant, so only surface area we need to calculate, right? But in the next one, it did not come out to be constant. When it did not come out to be constant, we converted into the polar form because we know that solving this will be a very tough task. So we converted into the polar form, and when we converted into the polar form, we got to know that it is coming out to be very easy. So this integration can be solved? Yes, very easily we solved this integration, we got the answer. After that, we saw for the cone. Here, the interesting part was that it was for the upper side as well, it would be for the downward side as well. So only one curved surface area a lot of people would find, but you need to notice one thing, that Z could be plus minus 1. So plus minus 1, so from upper side to downward side, both we need to find out. And then the last question we saw, it was between Z equals to 1 to 4. Here we did an error. What error we did? We did the error of taking R equals to 4, but actually the radius is 2 here. Value of Z is 4, but the radius is 2. Right? So radius is 2, so R is going from 1 to 2, while theta is again completely moving from 0 to 2 pi. In that manner, we solved this question and we got the answer. Understandable? So surface area we have seen the length as well, and everything we have seen, and we are now getting comfortable with the double integral as well. Now we will be getting comfortable with the triple integral as well. It is nothing. Triple integral is also same. Understandable? So let's meet in the next lecture. Okay then? Yeah. Thank you very much. In the next lecture, we will get started with the volume. Yeah. Thank you.